Hi Vinay. So today we'll be doing the two powerful packages, that is Numpy and Pandas. Okay, we'll be starting with Numpy today, and tomorrow also we'll be continuing with Numpy. I don't want to rush with the concepts. Okay, I always say that I never want to rush any of the concepts. So I don't mind to go as much as slow as possible, unless until you people say yes, you got it. Okay, that is what I expect from you people. So try to understand and ask as many doubts as possible. I'm ready to help you. Okay, but make sure that you're not skipping any of the concepts and you're not carrying forward your doubts. That's it. Okay, so there's two packages, what we call as Numpy and Pandas. Most of the machine learning packages, okay, are built on top of this. Okay, when I say Numpy and Pandas, these are the beautiful packages where this Numpy is used to do mathematics and statistical analysis. Okay, this is basically used to do mathematics and statistical analysis. Okay, and this Pandas is used to work on the data handling. Okay, it used to work on the data handling. As we know, the machine learning is a concept which basically stands on data, statistics, and mathematics. So these two packages are really very important. Okay, so when we want to understand NumPy, especially for the freshers who are attending some interviews, most of your questions will be on this NumPy and Pandas. Okay, most of the cases they'll be asking you how to extract the data, how to slice the data, how to dice the data, and how to get the relevant data. Given a scenario like I want to know who is having the highest marks out in the entire university. Okay, and which person is getting the highest salary, something like just like how we do SQL query. Okay, SQL query is like we write some SQL syntax to get the output, but in Pandas we follow similar methodology, but the syntax varies. Okay, it's something very different. Okay, and we will see to it what is NumPy and what is Pandas and how we do. Okay, so I'll just start with this NumPy. See, this NumPy is actually an array based. Okay, it is basically, we call it as an array based programming. Okay, in programming language we call it as an array. What do you mean by array? Group of similar data types, we call it as an array. Okay, group of similar data types is called as an array. In especially any programming languages, if you take, we give a general definition for array like this: group of similar data types, we call it as array. So what do you mean by that? I mean to say that I want to store numbers. So if I want to store some numbers, the numbers is of similar data type: 2, 3, 5, 9, 10. All these are numbers. Okay, I want to store this group of numbers under one bucket. This is called as numbers. So this is called as an array. That is group of similar data type. We call it as array. That makes sense. So how to create this array, how to work with this array, what are different operations, all this will be learning using a package called as NumPy. Okay, and most importantly, whenever you're working on a package called as NumPy, we need to have this NumPy package in our environment, in our Python environment. We need to install this NumPy package. Luckily, we are installed with Anaconda. Since we are working with Anaconda framework, the NumPy package is already been installed previously. Mean to say that as soon as you install Anaconda, all the machine learning default libraries would have been installed. So let us not worry about. Okay, so how to which are the packages to be installed externally, we will be seeing. Okay, if few packages say the package is not found, and I'll teach you how to install those packages, provided there are few packages. Again, rather than say it as few, the most important packages required for machine learning operations is already being installed by Anaconda framework itself. That is the reason we always say first install Anaconda framework, so all the machine learning libraries would have been installed. Okay, so what has been installed? NumPy, yes, so NumPy would have been installed. Okay, Pandas is also installed. There are like hundreds of libraries which is already been installed when we install this Anaconda. Okay, our intention is reading this library. We call it as library. We call it as a package. Okay, we call it as package or a library. What do you mean by package? Group of different functionalities. Okay, we know different functions, right? Group of different functions, a group of different classes under one block, we call it as a package. So multiple classes together, we are named inside one name called as NumPy. As simple as that. Okay, so NumPy is a package. Similarly, we have one more package called as Pandas. Pandas is one more package. Okay, there are two different packages. We will understand the syntax with how to work with Pandas, how to work with NumPy, what are the functionalities. Really, I'm telling you, you really attracted to these packages. Okay, it's like beautiful packages. You don't even imagine that all these things can be done in NumPy, because lot of mathematical operation, if you want to do this in Java or in C++, okay, you can't even imagine the pain of the developers. Okay, just because all these packages are there in NumPy, the things are going very fast. Okay, the developers effort are really reduced to a lot. Okay, so we'll be seeing it how it works. Okay, let us directly jump to practicals, because I don't want to go to theory perspective on these concepts, because most of the concepts are practical oriented here. So I'll directly jump to practicals. I have two files. One file is something with respect to basics, and one more file is advanced. Okay, so the two file is already been uploaded in your portal. Okay, mean to say that you can go for okay, the portal, your you can just log in. All the notes has been uploaded in the module. You can just download and start working on it. Okay, so it has been done today evening, so not to worry about it. So you can just go to and check for your particular files. There are two files which has already been uploaded. Okay, so now we are working on this numpy. We say import numpy as np. Okay, I'm importing a package called as numpy. Okay, what is this numpy? Numpy is a library written for scientific computing data analysis. It stands for numerical Python. Simple. Numpy mean to say numerical Python, as simple as that. Okay, this used to do what? Scientific computing and data analysis. Okay, the most object in Numpy is nd array. I told you Numpy works on array. Simple, don't worry nothing about it. Numpy works on array. Which array? Homogeneous array. What do you mean by homogeneous array? All the data types are of similar data. Okay, I mean all the data is of similar data types. Okay, we can't have a mixture of numbers, strings, okay, or a float value. No, all the data types has to be a single value or a homogeneous value. Okay, that is what I mean to say. Okay, now we'll be importing a library called as numpy. How to import? Import numpy as np. Np is an alias. Okay, np is an alias. And never make a mistake by saving your file as numpy alone. Don't do that mistake. Okay, so my file is numpy. For example, I named it as numpy underscore basic underscore matrix. Okay, and don't save as numpy, because when you import this file alone as is called as a module. Okay, as a package. Okay, so now when I say import numpy, it will import the file you have created. It is not calling the numpy which is there in Python library. So make sure that you are not saving the file name as the existing libraries. Do not save the file name as numpy or pandas. No, don't do that. Okay, so I'm importing numpy as np. I'll just run this. Now I'll create an array np.array 2, 4, 5, 7, 9. I'm creating an array. The syntax to create an array is np.array. Okay, it is 2, 4, 5, 6, 7, 9. I'll just clear the outputs so that you people will be clearly understanding. All output clear. Okay, fine. I'll just run from beginning. Okay, so np.array 2, 4, 5, 6, 7, 9. Print array 1d. Print type of array 1d. I'll just show you. Okay, it is 2, 4, 5, 6, 7, 9 are the arrays. When I say np.array, what do I mean to say? I mean to say that whenever you want to create an array, the syntax is np.array. Okay, I tell you the syntax to create an array is np.array. If you ask me, Vinay, why are we creating array? We have list. No, I agree. You have list. Okay, why are we creating arrays? We have lot of mathematical functionalities which is present in array alone, which is not present in your list. List is a Python library. Numpy is something numerical Python. Mean to say lot of machine learning operations runs on mathematics and statistics. So all those actions, all those functions is present in Numpy. That is the reason we always say to create a Numpy array. So np.array, what is the list? It is 1, 2, 3. Okay, simple. Okay, when I say 1, 2, 3, that's it. It means to say you are creating a list of numbers 1, 2, 3, and you are putting inside an array. np.array, you are converting this list to array. It is something like that. Okay, so np.array, and you will give a variable. You will inside a variable called as p1, a1, or whatever it is. I'll just name it as a1. Let me say. Okay, so this a1 is the array. That is what we are doing here. Okay, we have created a simple numpy array. np.array 2, 4, 5, 6, 7, 8. Okay, I run this. You are done. Okay, let us create a two-dimensional array. So two-dimensional array mean to say 2, 3, 4, and 5, 8, 7. So when we do this, let's see what it is. Yes, the two-dimensional array. Now the question is, can we convert the list to array? So what is the difference? What is the difference between the list and the array? We will see that. The two-dimensional array mean to say that 2, 3, 4 is one set of elements. 5, 8, 7 is one more set of elements. In between there is a comma, mean to say that it has been bifurcated by the dimensions. Mean to say that 2, 3, 4 is the first row, 5, 8, 7 is the second row. This is how it works. Okay, this is how we create a two-dimensional array. Now we have a list. Okay, we have a list. Okay, so we have 3, 6, 7, and 5, and we have 4, 5, 1, and 7. I told you here we have created a simple lambda expression. And what is the lambda expression? I told you we'll be doing a lot of lambda expressions in machine learning. Okay, we have list 1 and list 2. List 1 and list 2 are the arguments. I created list 1, list 2 are the two arguments, where list 1 will go and sit in x, list 2 will go and sit in y, and x is to y, x into y we are multiplying. If you ask me, Vinay, there are multiple elements now. How come each and every element is iterated automatically? Because I'm using a function called as map. What map function will do? I want you people to recall the map function automatically maps each and every element of the particular list element. I mean, in the list array, whatever is there in the list, automatically the element gets mapped. That is the reason we are using map. I'm using map of lambda x into x comma y, x into y, list 1 comma list 2. List 1 goes and sits in x, list 2 goes and sits in y. We are multiplying x into y and we are mapping it. So when I say map, automatically each and every element keeps on iterating by itself. That is the reason we are doing it. Why did I do this? The reason I did this is, now let me say we are doing like this. If in case, if I create, okay, if I create a simple list, a simple array, okay, I'll create a two array. A1 is equal to np dot array. I'll create an array, the same numbers, let me say, which is 3, 6, 7, 5. 3, comma 6, comma 7, comma 5. Okay, then I'll create one more array which is a2. A2 is equal to np dot array. Okay, then again I'll create an element which is 4, comma 5, comma 1, comma 7. I have two arrays. Now I don't want any lambda functions here. That is the advantage. I can directly do something like this. Print or a1 into a2 directly. Let me say a1 into a2. A1 into a2. That's it. See, here we would have written some lambda functions, right? But when it says a numpy array, basically this numpy is created to do mathematical operation. Then why we want to burden so much using lambda expressions and all? No. Directly we can do multiplication if you're using the numpy array. I just wanted to show one advantage. Okay, simple, very advantage of it. We'll see lot of things, okay, down the line. Okay, so now if you ask me, Vinay, what else is present in this numpy array? One is you created an array, you created a one dimension array, you created a two dimension array. What else can be created? What else can be created? Yes, what else can be created is we can create array of zeros by using a function called np.zeros. We can create array of ones by creating a function called np.ones. np.random to create array of random numbers. np.arange, just like how we have a range function in Python. np.linespace, create array of fixed length. How are these functions there? Can we see an example for each one of this? Yes. The first function what we take is np.ones. Okay, I take np.ones of 5, mean to say that I require 5 ones. Give inside a variable called as o. Let me print this. See, you have 1 dot 1 dot 1 dot. Question is, Vinay, like it is giving 1 dot 1 dot 1 dot. Where you told once, no, it has to be integer value. I understand. In np dot ones, we have something like d type is equal to int. If you do this, then you'll be getting an integer value. We didn't know, no. I know you people don't know. What you can do is you can just do np dot. You can just do np dot ones. As I told, the shortcut shift plus tab. Okay, it will give the complete syntax. If you want to know what is there, just go there in the backend. It says what are all the different arguments. See, it says what is the shape you are expecting, what is the data type you are expecting, order is equal to C. What is it? The complete documentation is present. So don't bat anything. Okay, we are not biating anything. Okay, I'm just, because I'm used to it, I'm just doing it. Or else you people can just see here and you can start solving it. Right? So how to create array of ones? And the question here is, why do we want to create array of ones, man? What is the use of it? Very important. In most of the machine, and one I have two questions here. One question is, see, I'll only pop up the question, I'll say the answer. Okay, the question here is, when I say np.ones, Vinay, do we have np.5s, np.10s? No, we don't have np.5s, np.10s and all. We have np.1s and np.0s only. Why is like that? Because understand, while working on the machine learning operation, we have something like yes or no, 0 or 1 case. Most of the cases is a binary classification. Okay, when you want binary classification, let me say that I have 10,000 rows. Okay, 10,000 data items. In 10,000 data items, I have 5,000 zeros and 5,000 ones. So I can just say np.0 5,000, np.1 5,000. Just concatenate. That's the reason they have given np.zeros and np.ones. That's it. But we don't have this np.50, np.60s, np.70s. No, we don't have that. Okay, we have np.zeros, np.ones. What np.ones will do? It will generate a series of ones. np.zeros, it will generate a series of zeros. Now the question must be, Vinay, is that possible to generate two-dimensional data? Yes. How to generate two-dimensional data? np.ones 5, 3. 5 rows, 3 columns. Simple. And again you're getting 1 dot 1 dot. Simple. If you change d type is equal to int, then automatically this will become integer values. Simple. Okay, this is about it. Okay, let me go for np.zeros now. Similarly, np.zeros of 5, okay, you're getting a series of zeros. np.zeros of 2, 2, 2 rows, 2 matrix, data type is equal to int, and print z2. right? Let us revise now. We saw three different functions. One was np.array, which we created a one-dimensional array. Then np.array, where we can create a two-dimensional array. Then we saw np.zeros. Then we saw np.ones. What is this numpy? Numpy is a package basically used to do the mathematical operation. The numpy, the default data structure behind numpy is array. I repeat, the default data structure which is present inside numpy is numpy array. We call it as nd array, n dimensional array. I'll show you, like I'll just write it on the screen. Okay, we call it as nd array. Nd array is nothing but n dimensional array. If someone asks you what is the default data structure behind numpy, it is nothing but n dimensional array. This is what you need to understand. Okay, so we saw something with respect to how to create an array, how to create array of zeros, how to create array of ones, how to change the data type, how to create one-dimensional array, how to create two-dimensional array, and how to multiply two arrays. This was simple concept what we learned till now. Let us go forward so that later I'll give you people a chance to ask doubts. Okay, so let me take this forward. We will just take it to next level. We have something like np.random. You say, like, I need a random number generators. I want to get some random numbers. Okay, so if you want to get some random numbers, you have a function called np.random.random. Let me show this. See, np.random.random. If you say no, I require random of 30 numbers. Very simple, then you can just do np.random.random 30. You'll get a 30 random numbers. And the question must be, Vinay, we generated random numbers, but you're getting a random numbers of 0 to 1 value, but you require a random integers. Do you have a function? Yes. I know, like, these questions are very common. Okay, so they also have a function to generate a random integers also. Okay, we'll see that function. Okay, we can generate random integers. This is a random, floating value which ranges in terms of 0 to 1. Okay, advantages of it we'll see in machine learning. We'll see a lot of cases we'll be using random.random. Okay, so if I just give random.random, only one number will be generated. That's what I wanted you to show. Okay, random.random is like matrix format. Yes, 2, 3. 2 rows, 3 columns of the matrix numbers. This is what, okay, this is what it is. It makes sense, right? So let's go for the next function, which is arange. Just like how we have a range function in Python, we have arange function in np.array. What is the difference? The difference is arange will give you the list format, but np.arange will give you the array format. That's the difference. Okay, so here I have 2 to 10. When I say the data type of this AR1, it would be numpy nd array. Okay, let us check. I don't know. Let us check. Let me say print type of AR1. So quite long time. Yes, it says see np.nd array. But if I just use range function, it will be what? It will be a list, right? It will be a list. So you'll want nd array. You got it. And the question what must be popping your mind is, what is the advantage of using it, man? Like you're creating an array, you're creating a list of elements. I mean, whatever is possible in the list, it can be done in array. Nothing. No, that's it, right? We are not yet went to applications. We are not even into applications. I'm just showing you what all can be generated. Next, we will be learning what are the different applications, what are the different advantages of working on this numpy array. That time it will be very much clear for you people who will understand, oh, this is the reason you must use numpy array. Okay, fine. So we have np.arange of 2, 10, 2. We need to say that we are generating the values from 2 to 10, 2. As we know, start from 2, end at 10. Every time increase it by 2, right? So when I do print, it's 2, 4, 6, and 8. Beautiful. Okay. So now we are done with 4 different functions, which is nothing but np.zeros, np.ones, np.arange, np.random. Right. So these are the different functions what we learned till now. Okay. So I want you to make sure that you don't have any queries with respect to these functions. Okay. If you have any questions, please ask me so that I can pause and we can continue later. Thank you. So we have one more function here called as line space. Okay, what this line space will do is, I'll just show you an example here. We are given as 10 to 13, 25. Mean to say that I require series of numbers from 10 to 13 and I require 25 numbers. Here you can understand, if you people knew about arithmetic progression, right? There's something called as common difference. What is the common difference? The common difference here is 10.125 to 10, it is 0.125. 10.25 to 10.25 0.25. That is, it is generating the common difference numbers from 10 to 13, okay, with 25 numbers. If you say, Vinay, then we do one thing. I'll give 10 to 13 and I'll give 2. Expected answer, 10 and 13. Okay, I'll give 10 to 13, I'll give a difference as 5. See, 10, 10.75, 11.5, 12.25, 13. There is a common difference which is maintained. If you ask me what is the application of this? Application of this is, let me say, I want to generate a graph like this. Okay, I want to generate a graph like this. We want to generate a graph like this. Values are 0, 0 0.5, 1, 1.5, 2, 2.5. Here again 0, 1, 0 0.5, 1, 1.5. With equal distance I want to go so that I'll get a linear graph. I get a very good linear graph. This is an advantage. Okay, one of the scenario where we'll be using it in visualization. Okay, the advantage of using line space. Okay, line space will give you the common difference numbers. Okay, you can understand like that. Okay, line space used to give the common difference numbers. Okay, this is about the line space function. Okay, so we have already created an array. We understood how to create an array. We understood okay, how to work with the zeros, ones, and all such things. Now I want to understand about the structure of the array and the content of the array. I want to understand extract the values present in the array, and what's the structure of the array, what's the dimension of the array, all such things. For that we have few more functions. The first function is shape. What shape function will do? It tells the shape of an array. It tells us how many number of rows, how many number of columns, and we have something like d type, which tells us the data type of the array. Ndim, it tells us the number of dimension, whether it's a 2 dimension or 1 dimension. Item size, it tells memory used by each array elements in bytes. Mean to say that, okay, if the array is consisted of the integer numbers, it will tell that, okay, it is like a total size of int. It is one element as considered 4 bytes. I'll show you an example, don't worry with that. Okay, reshape. Already the array is taken some particular shape. Let me say there are 6 elements, which is 1 dimensional, and you can change the shape with 2, 3. Mean to say that we can convert to 2 rows and 3 columns. That is quite possible. Okay, that is reshaping the array. So structure, already defined an array, I can structure the array, or I can redefine the array. I can get the content inside the array using something called as structure of the content of array concept. Okay, so the first function what we see here is a shape function. Let me see how this will work. Okay, I have created an array which is having something like this: np.array 5, 4, 10, 20. Okay, I mean to say that it is a 2-dimensional array which is having 2 rows and 2 columns. So let me print that array. See, it is 2 rows and 2 columns. Beautiful. Okay, now I'll ask the shape of the array. What's the shape of the array? It says 2, 2. It says that it is having 2 rows and 2 columns. Array 1.date type, mean to say what's the data type of the array? Data type of the array is int 32. It is 32-bit integer, right? I mean, it's int 32 basically. So array of ndim, what's the dimension of the array? Okay, it says it is 2 dimension. Beautiful. What is the item size? When I run for the item size, it says 4. What do you mean by 4? It says that each element is taking 4 bytes, right? Because integer by default takes 4 bytes, no? Because as you can see here, int 32. When I say 32, 32 means to say 4 bytes. It says each item in the array is taking 4 bytes. So totally, what is the total bytes? It is like 4 into 4, which is 32 bytes, the total size of the array. And I can reshape the array now. We reshape in terms of it is having 2 rows and 2 columns. I can reshape it to 1 rows and 4 columns. Can you see this? You can see you are reshaping it to 1 row and 4 columns. This with respect to array 2. Okay, so these are the additional function which is there in respect to working with the context and working with the structure of the array: shape, data type, number of dimensions, item size, reshape. So these are the important functions which is there. I'll give a chance to ask you any doubts. Please hold on for some time. Okay, so now we'll go for something called as stacking and splitting arrays. Mean to say that if there are 2 arrays, array 1 and array 2, how can I merge 2 arrays? Okay, merging in terms of there are 2 types of merging. One is I can merge one below the other, which is horizontal merging. One after the other, which is called as vertical merging. Okay, that is column can be merged or rows can be merged. So we have 2 types of stacking called as H stack and V stack. Okay, we call it as H stack and V stack. What is H stack and V stack? H stack used to do horizontal stacking. V stack is vertical stacking. So how is that? We will check it. We are defining 2 array np.arange of 12, 24 reshape of 3, 4. Mean to say that I'm creating an arrange 12, 24. So expected the output is nothing but numbers from 12 to 24 and 3 rows and 4 columns. So numbers will be from 12, 13, 14, 15, 16, 17 till 23. Okay, and np.arange of 20. Mean to say that it is creating an array of numbers till 0 to 20. It is 5 rows and 4 columns. Let me print the array. Yes, you can understand this is the array what we have got. Okay, one is having 5 rows and 4 columns starting from 0 to 20. Okay, one more is 12, 24 with 3 rows and 4 columns. 2 arrays has been created. Great. So what is the number of rows? Number of rows is 3 here. Number of columns is 4 here. Okay, in both the arrays. Now I can merge these 2 array not horizontally. Mean to say that I can put one below the other. I want you to understand. I can put this one below the other because the number of columns are the same. You want to put one next to other. In that case, the number of rows has to be the same. I will repeat. if you want to merge two rows horizontally, I mean one next to other, then the number of rows has to be same. If you want to put array one below the other, then the number of columns has to be same. Okay, we'll just run this. Okay, we'll try to understand how is it. Okay, so np.vstack array1 of array2. Let us understand what will be the output. Vertical stack mean to say one below the other. So 12, 13, 14, 15 till 2023 is been merged to 0, 1, 2, 3. I can rename to a new variable. Okay, if you ask me why are we doing this, okay, why are we doing this, is there any scenario? Yes, basically whenever we work on image processing, okay, image processing, we do some vectorized multiplications, okay, and we do something with respect to pixels. Okay, we try to merge two images, or we try to do some there's a lot of mathematical operations. Don't worry about application perspective as of now. We do a lot of mathematical operations with respect to h stack, v stack, and all those such things. Okay, because let me say the dimension of the array. Okay, there's a two arrays and I want to merge array1. Array1 is with respect to some value, array2 is with respect to some other value, with respect to two images, whatever it might be. In that case, if you want to merge one below the other, I'll be using something called as v stack. You want to put one next to other, then it is h stack. But in the case of h stack, you would have understood by this time that h stack usually will be preferred when array is next to other. Mean to say one next to other is what array, h stack. Let me see the scenario now. I'll just run this. So in this case, when I say a range of 12 comma 24 dot reshape 3 comma 4, okay, here one below the other is only possible now because np dot vstack I had given. I want you to understand np dot vstack. In this case, what is the shape? 3 rows 4 columns, 3 rows 4 columns. Let me put h stack here. What happens? Let me see. See, one next to other. It is one next to other. So if you want to merge two arrays one next to other, make sure the number of rows are the same. You want to merge two arrays one below the other, the number of columns has to be the same. This is with respect to h stack and v stack. That's it. Okay, so let us revise these concepts now once again. Okay, we are done with zeros and ones. After that, we started with np.arange, then we came to np.linespace. np.linespace will give you the common difference between the numbers. Okay, was the application putting a plot, putting a linear plot is the advantage of using line space. Okay, then we got to know we have a few different functions to know the structure of the array, which is something with respect to the shape of the array, the number of dimensions, or it might be the data type, the item size, or reshaping the array. All these are the different structure wise operations what we can do in array. So that we are doing it here. Okay, then we are trying to stack, we are trying to put one array next to array, that is h stack and v stack. If you're trying to put one array next to one more array, that is h stack, one below the other is nothing but v stack. We are trying to do those things also. We did it and we got the output. Okay, this was with respect to the core different functions which is there with respect to creating the array and understanding the array. But till now we didn't see any application as such. Okay, we are not seeing any applications. Okay, where all we will be using it, what are different things. Here at the bottom, here I am doing very simple kind of mathematical operation. See, since because it's an array, we can do a lot of mathematical operation within a single line. You want sign value, np.sign. This is not present with respect to list. Okay, all this is not present with respect to list. Okay, in the list we can't do sign operation. Then you want to do some mathematical calculation, call the mathematics package, then call it, then do some alterations here and there, then start working on it. But since it's an array, it's a numpy array, directly there are a lot of mathematical operation which can be done within a single function. Okay, I'll just show you this. See, so sine theta, sine of the value, we'll get it, cos of the value, exponent of the value, log of the value, whatever. Okay, lot of mathematical operation can be done within a single function just because you are using the numpy array. This was not possible with respect to list. Okay, that is the reason we need to work on this numpy array very seriously. Okay, because it is lot of advantages. This is not the only function. It's not the only sine, cos, exponential, log. I'll be showing you a lot of other functions which is related to numpy. Okay, I'll show you one more example with linear algebra. See, I created np.arange of 10 comma 4 comma 1. I'm reshaping it. Okay, so I got the value. I got something like this, print a. So I got 10, 11, 12 and 13. I can do inverse of the matrix. Within a single line I can find out the inverse. This is a matrix. I can find the inverse of a matrix. Simple. I'll get this. Okay, how to find out the inverse of a matrix? Don't worry. If you have a recap, good. If you don't know how to find out the inverse, we will see when I there's a session on mathematics. There will be one session on basic mathematics, okay, by the professor. Okay, she'll be doing about the basic mathematics, what is required for you people. Don't worry about it. Okay, so linear algebra determinant. If you want to find out the determinant of the value, okay, I'll just find out this. You can find the determinant of the value is minus 1.9. Okay, it's just a single function. Okay, eigenvalues. Eigenvalues is like a very beautiful topic. Okay, we'll understand a lot of things in eigenvalues. Okay, so why eigenvalues are required? There's a beautiful algorithm called as PCA, principal component analysis, which completely stands on eigenvalue. There's a mathematics behind eigenvalues, like the mathematics behind the algorithm, which is something called eigenvectors and eigenvalues. So there's a PCA where we'll be doing the PCA algorithm. This completely stands on eigenvalues. Okay, you would have understood, you would have thought in when you are doing in your high school sessions or in your +1 or +2, why are we learning mathematics? But we'll understand when it comes to machine learning. And please don't get scared. Okay, it's not that you need to go back and lose on trigonometric or calculus part. Okay, it's not that you don't do any kind of calculus or trigonometry in detail, but just understanding it is always a good. It's always good to understand. Okay, so np.math matrix, we got it. So this is with respect to the basics of understanding what are the different functions which is there with respect to array. Okay, so we have a lot of other functionalities with respect to array. We will see it. Okay, so on basic, these are the core functionalities which is there with respect to numpy array. So this is about, now we are in a scenario where we will be understanding what are the use cases of NumPy array. We got to know how to create an array, how to create one dimensional array, how to create array of zeros, how to create array of ones, and how to reshape the array, how to know the dimension of the array, how to know the shape of the array. Okay, and we got to know how to do the dot matrix and I mean dot matrix of the multiplication, how to find those eigenvalues, eigenvectors. All those was with respect to the basic functionalities. But is that the only thing what we can do in the NumPy array? No, you'll be seeing the beautiful things what we'll be doing in NumPy array. You will really, you really feel like, wow, this much is possible with respect to NumPy array. Okay, so we'll see what are those. Okay, we'll be continuing this session from the previous class, which is basics of NumPy. And here I'm importing something called as warnings. Warnings is something like I don't want to see. Sometimes while we're walking, there are few warnings which really we are not interested at. Okay, so I say that, boss, please ignore the warnings. So I say warnings dot filter warnings of ignore. Okay, I'm just ignoring it. So no, nothing new to learn here. It is like I'm importing the warnings package and I say warning dot filter warnings as ignore. I just say ignore the warnings. Okay, I'm just doing it. Then I say np dot set print options threshold is equal to 100. Okay, threshold is equal to 100 mean to say that I'm trying to put the threshold value of the array. Okay, when I want to print something, I'm putting some threshold value which is 100, means to say the 100 elements, if I can say. Okay, the size which I'm putting the threshold is 100, so don't maximize more than that is what I'm telling here. So because I'll put something like np.random.random 10,000, so I can't print 10,000. If you want to print 10,000 elements in the screen, then just imagine I must keep on scrolling. So I say threshold is equal to 100. I'm just fixing the threshold value just for the printing purpose. Okay, there's something called as numpy dot set print options. In set print options, what else we have? I told you, no, you can just do shift plus tab. You can see lot of functions present inside the print options. Lot of arguments are present inside the print options. Don't worry about it. But as of now, I'm just pushing the threshold as 100. Good. Now the version of Python when NumPy what I'm using is 1.9.2. I'll clear the output so that it will be clear for you people to understand. Okay, so I'm doing this. Np dot version is 1.2.2. Then I'm creating a simple empty array. Okay, empty numpy array. We say np dot empty 2 comma 2 integer data type. Okay, then I'm printing the empty array shape, empty array size. You would have think like, Vinay, you're doing an empty array, but the values inside, yes, by default it will take some random value. I'll repeat, by default, whenever you create an empty array, it will take some random values. That is what I want you to understand. What is the empty array? Empty array mean to say that there is no values inside it. Okay, it doesn't have any values. But you can see the values. Those are the random values which is generated, because whenever I want to say that I want to assign the space of 2 comma 2, if there is some value of integer data type inside it, only then that makes sense, right? Or else I say there's an empty array with no values, size of so much. How come that would be possible? So what the array will say is, if you create an empty array, I will generate some random values by default. So the random values are something like 1 comma 4, 5 comma 4. Okay, so the random arrays which has been generated. I'm just doing this. I just call this, and I'm creating np.array, which is just an empty array, and I'm creating np.array 1 comma 2. Fine, and I'm creating two arrays, A and B, and I'm creating a function here. Try to understand the code. Try to understand because I'm trying to make things bit complex. I myself am trying to make the bit complex just because of the reason there are a lot of functionalities which you people need to learn. Let us try to understand each one of it. Okay, I have np.array, which is an empty array, np.array which one rows and two columns. Okay, now I'm telling check empty of a, right? When I say check empty of a, I'm trying to check whether array a is empty. If a dot size equal to 0, then I say print a empty, else I say print b non-empty. Simple. Okay, just I'm trying to check whether a is empty or not. Okay, if you ask me why did we learn that if else all those things, just a simple example here where we are using it to check whether array is empty or not. I'll just run this. It says array a is empty and array b is non-empty. Okay, array is empty, array is non-empty. Okay, when I say previously you created something like mp dot empty array. Okay, in this case whenever I just wanted to show you here, whenever I create like something np dot empty 2 comma 2, here it was an empty array, the default value will be posted in empty array, but here I'm not even telling the size of the array. No, I'm not even telling the size of the array, so it's an empty array for that matter. So I say that np dot array, okay, and it's a blank array, np dot array of one rows and the two columns. I'm calling the check empty function. I'm trying to check whether the size of the array is 0 or not. Okay, simple. Okay, Vinay, can you tell the use case of this? For example, let me say that I'm reading some file, some Excel file, and assuming that the Excel values have been converted to Numpy array format. You are assuming you're automating the things. You're doing some automation. Okay, in automation process, you're assuming that like there are some values. Okay, there are some values inside it, but actually there are no values. In automation, what we do is we try to check whether it is an empty matrix or not. If it's an empty matrix, we say we raise an exception. We raise an exception telling it as boss, the matrix is empty, put a log, go to the log file and say the whatever the file you read was an empty. So just a scenario to check whether it is an empty array or empty matrix or not, we'll be using a function called as check empty, like this, a simple function what I have written. Okay, so this is what we have understood. Let's go for the next function, checking the element count. Okay, check the element count. We have np.array with the element here and np.array of one row, two columns, and I create some function called as get elements. This get elements I'm passing an array. Okay, I want you to concentrate. There is one array which is created np.array, and one more array which is np.array, where the first one is empty, second one is having one row, two column. Okay, so I'm having two arrays here. I'm calling the get elements function. I'm passing both c and d. Okay, if you say what is the size, I'm returning c dot array and dim. See, the reason why I created this particular file is make you people to get revised with the functions concepts, get revised with the if else condition statements. Okay, I would have skipped all these concepts, but I want you we have a revision with respect to Python and to also understand about the NumPy concepts. That's the reason I'm making small functions, and this was contributed from Kaggle also. Okay, beautiful person, by name Raj has contributed this in Kaggle. Okay, I'm utilizing the same file here also. Okay, and I'm did few modifications there. Okay, but yes, so you must understand that it's a I'm just creating get elements of C array, return C array dot end dimension, C array dot size. We're just running this. Okay, so the element count is 0, element count is 2. Okay, let's go for the next function here. np dot a range of 4 comma 12, print a, the shape of the array. The shape of the array is 8 comma, mean to say it is 8 rows and one column. When you say one column, doesn't mean to say it has to be represented. When I say 8 comma, it is by default understood it is having one column. 8 comma mean to say it is 8 rows and one column. Fine. So similarly, I have one more function called as shape. Okay, in the shape we have something like np.arange 12 comma 30 comma 3. So revision again, 12 rows. Data from 12 to 30. Okay, which is having the space of 3. Okay, and there is no dimension. If I say that Vinay, I want it to be converted to a matrix format, you have here 6 elements. No, you can just say dot reshape and you can change the shape of it. Okay, I did it here. Okay, see, np dot a range of 12 to 30 mean to say that I require the series of values from 12 to 30 with a space of 3. So what are the elements I'll be getting? 12, 15, 18, 21, 24, 27 are the elements which I get. I can convert it to 2 rows and 3 columns using the function called as reshape. See, I'm assuming that you people are taking the notes, so just make a small notes so that you will understand what are the functions, when you'll be using, why you're using, and all those things. I'll keep on repeating functions. I'll keep on repeating things, different functions. It's a repetition again. What I did in the previous slide, okay, previous presentation, the same I'm doing it here also. But there is few differences. We'll see what are all those. Okay, so we did np.arange, np.reshape, done. Okay, now we create np.random integer. I want you to understand it is random integer. That time what we did was np.random. Here we are doing np.random.randint. Okay, so what is the output? It is 70262. How come you are getting 70262? I mean to say that I'm getting a random integer. So random integer you're getting 10. 10 is a decimal value. Mean to say that random integer of 10, then I say size is equal to 5. Okay, so I'm getting a random integer values of decimal values, and size is equal to 5. I'll change the size is equal to 6. You must understand it is a decimal value. Vinay, you are given 10. So what are the function which is present? Then just very simple. I told you we can do something like this. np dot random dot rand int, open the bracket, shift plus tab. You'll understand what are the different option which is present. Okay, it will show you. Okay, if you want something like decimal, what to do? You want something like a binary value, what to do? So where like binary 2. Okay, in the terms of 5, then what to do? Decimal value. So like this we keep on getting the different values. Okay, so you can, I mean, I don't want to cover each and every arguments as such, because assume that you people need to practice, and we'll be seeing down the lane. Just understand what it will do. Okay, and arguments and all we can learn as and then required. No need to by heart anything. Okay, so this is about random.randint. What we learned previously was random.random, which used to generate random numbers. Okay, random.random will generate a random integer values. That's it. That's the only difference between random and randint. Okay, now we'll go for the next one. Okay, so what it says, random.randint. Sorry, there's some change. We'll check what is it. Just hold on. Oh, sorry.
What is the second line, Vinay, that np dot?
No, that was a mistake. Okay, it was a mistake. Fine, I just try to write something, but it was a mistake. Okay, fine. Random.randint. Okay, the first argument is 10, mean to say decimal value. The size is equal to 6, mean to say I'm looking for the 6 integer numbers. Okay, I just tried to do this, and I thought of typing something with respect to binary value. I think I was supposed to type 2 comma size is equal to 10. So I'll give this to b is equal to, then I say print b. Let's try to understand what this will do. So it's generating a series of random binary numbers. Okay, size 10. Okay, that's it. Nothing more than that. Right? Okay, so create a numpy array with size of 2 comma 3. Here again I'm changing the size also. So I'm getting the random numbers 96414. If you ask me where do we require these random numbers? Okay, so where do we require these random numbers? In terms of, one is through imputation. The second thing is while selecting the indexes. See, I'll tell you one use case where random is required. Okay, a very simple use case. I want to train my machine learning model. In that case, I have, like, let me say 100 rows. Okay, 1 2 3, like this I have 100 rows, let me say. Okay, and I want to train my machine learning model. While training, I want to select the random values, let me random 60 numbers, 60 rows. Okay, I don't want my model to be biased. When I say biased, I can't force my model to tell choose only 1 to 60, and 61 to 100 let it be for testing. No, I can't do it. Okay, so what I do is I'll be saying some random generator. So the random generator will select the random numbers. Okay, any random numbers for that matter. I keep on changing it. I'll be showing you how the random numbers can be generated. Okay, so I mean there's something called a seed. There's something called a seed function. I'll be telling the seed function. That time you'll understand how to fix the values. But why the random numbers is generated? Because I want to select the random rows for training. Which random rows, that I don't know, because I don't want to make my model to be biased. If I force my model to say, boss, select only row number 1 to 60, every time it will select row number 1 to 60 only. That is, you are making the model to by heart. Okay, so I don't want to do like that. That's the reason we use something called as random integers, random numbers, so that the numbers will be generated at random. Okay, so this is all about it. Fine, we'll go for the next one. Okay, good. So we have random int. Then the next one is again okay, np.array Toronto and Montreal. Okay, I'm just doing this. Okay, x.d type. Okay, you can see that as I told you, array is a homogeneous data for that matter. You can't say that one can be integer, other one can be a string, and something like this. Okay, if you're doing like that, let us try to see what happens. Okay, I just delete this and make it 8. That 8 is also converted to string, because array is what? Array is homogeneous, right? Okay, it's homogeneous. Mean to say that we can't actually make sure, you can't actually change the values. Okay, you want to actually change the values. Okay, it has to be, if you put multiple data, it will be converted to the higher data type. I told you the concept of this in typecasting. What happens in typecasting? The lower data type automatically will be converted to the higher data type. Okay, the same happens even here. That's it. The same will be happening here
Vinay, I
also.
have a question,
Go
please.
ahead. Go
Actually,
ahead.
two questions. So
Yeah.
one is, can we combine or concatenate an array and a list?
Yeah.
And the second is, can you please, I do remember vaguely the typecasting rules, but can we please cover that in detail, or can you share those rules?
See, it's like, I can tell you one simple example if you want to understand, because it's again not with respect to NumPy. The simple example for that is, so I'll just say here as print enter age. So age usually what happens? Okay, let me say enter number one. Okay, just for a recap, enter number one. So a is equal to int of input, right? Okay, I'll just do this. Then I say print enter number two. Okay, enter number two. Then again I'll do b is equal to int of input. Okay, then I say c is equal to a plus b. Then I say print c. Simple for that matter, very simple function. Okay, it's not even function. Number one, two, then three. You got it as five. Let me say that I am not giving this int. I'll just give like this. Okay, so I'll just give this input function. I'm not giving it as int. So what happens in this case? Okay, so it says that enter number one, two, three. So it is 23. Mean to say that you're not getting the answer as 5. What is happening here is typecasting. What typecasting? Even though you enter the number, automatically it took it as a string. Okay, so this is called as upcasting. That is, even the number was given, but number was automatically converted to string. That's what is happening here also, right? Even though you had given something like a number, okay, it was 8 in the previous case. I've given here 8, just a number, but since because you told it as string, automatically the 8 was also converted to string. The lower data type, which was the number, got converted to higher data type. This concept is called as typecasting. But when you try to convert from higher data type, which was a string, to lower data type, you are explicitly asked to put here as int. Okay, put here as int, right? This is what you need to understand. This is called as explicit typecasting, where it is taking it as a string, but I'm converting into integer. This is with respect to implicit typecasting. Got this, Pooja? I'm sure you will got it.
Yes, yes,
Yes.
I'm sure. Yeah, I got it. Okay,
Thank you.
and then can we combine or concatenate an array and a list?
No, I mean array, because it's not possible, right? Because what happens is array is a data structure which is of ND array type. Okay, so list is of a different data structures, right? So combining an array with the list is not possible. What you can do is you can convert the list to an array, then you can combine together. Am I clear?
Okay. Yeah.
Okay, that is possible, right? We'll see an example there. So how to convert the list to an array, we'll be seeing that as an example. Don't worry about it, right? So now we have something with respect to np.arange function. So arange function, which is having something like this, which is giving something like x. Okay, I'm giving dot x. Before setting the print option, I'm just giving x. Okay, I'll just run this. Let us understand what is happening here. So before setting the print options, I'm getting like this 0 1 2 9 9 7, something like this. Okay, you can understand this. Okay, after setting the print option, okay, after setting the print option, I can give something like this. I'll show you how it is. Let us try to understand. Okay, see, after setting the print option, if I try to print a, okay, so not a, let me say print x, right? Let's say print x. Okay, see, I want you to understand. So all the numbers have been printed here. Okay, I don't want to be printed. This, cases like this you'll see a lot of times in while working in programming. Okay, because I are given np dot a range of 10,000, you'll be getting 10,000 numbers. Okay, 0 to 10,000. I don't want to print. I mean, why ultimately I want to print all the numbers? I just want to know whether the numbers have been stored in a variable called as x. That's enough for me. So if that is the reason we do this, then again it becomes a problem. You're not supposed to do like this. So I always set the printing option. Okay, if you don't give the threshold, okay, I mean if you don't by default it is fixed. Okay, by default it is fixed, but if you want to truncate, okay, you want to truncate, I mean if you don't want to truncate, if you want to print all the values, you can give like this threshold sys is equal to sys dot max size. But usually we don't do this. Okay, we'll always put a truncation. We don't want all the values to be printed. We will truncate it. By default, what happens is it will be truncating. It will not print all the values. It just shows, okay, boss, this is what it is. Okay, if you don't want to give the threshold option, then by default it will take only 0, 1, 2, 3, and it considers to 10,000 and say all the values are there, just see and leave. Okay, but if you say that no, I want to print everything, then set the threshold to sys dot max size. This was a simple example what with respect to the printing options. Okay, so we have something with respect to np dot as array and converting to csv. I really don't want to rush all the concepts for today. I think we'll keep it for tomorrow. So tomorrow we can continue with numpy array, because this is completely a dry concept again. Okay, I don't want to push it completely for today itself. So till now, if you have any doubts, okay, please let me know. We'll just have a 5 minutes of recap of what we did till now. Okay, if you don't have doubts, I think we can wind up for today, right? So the simple thing what we did was we imported the warnings, filter warnings and ignore, and we did print options. Threshold is equal to 100. I told you if the threshold was not set to 100, what happened? What happened was all the values were printed. Okay, all the values were printed. But just because I'm putting the threshold value as 100, okay, it is limited to some particular value. Then np dot version. Then I'm printing the np dot empty. You know what empty array will be printed. Empty array will be there, but provided empty array will be having some value by default. Okay, I can create an np array like empty array like this, where no values are being taken here. And we saw different functions to see to get the size of the array, and to get what is the dimension of the array. And we got to know how to find the shape of the array, how to reshape the array, and how to see the a range values. Okay, all such things. Then we got to know by default the array will be a string value, right? That by default array will be a string. I mean, not a string value, but the data type is not given, it will be taken as string. If you can understand here, since the upper data type is string, even though you combine it with the number, if I combine this with a number, let me say like this, what happens is even 8 will be converted to string. Okay, this is what it is. Or else externally you can give the data type. You can give the data type as string, so that you have an option to decide the data type also. And we saw something with respect to the print options. Okay, what we saw previously, I set the threshold for what? Threshold for 100, but you can change the threshold. You can change the threshold to sys dot max size, so all the elements will be getting printed. This is what with respect to the numpy array. So the numpy array is a very, very, very important and the basic concept, which is really important for the data science and machine learning terms. Okay, we have a lot of functions to see tomorrow with I mean in the next session. Okay, next session basically it is on how all this, what is flip, what is flop. A lot of functions are there. You'll really get attracted with all these functions. You'll understand the value. Why do we want to create the numpy array? So you really don't even care about the list functionalities. Once when you use to this numpy array, right, you will always come to numpy array, because we have a lot of functionalities which no more other data structures can give it to you. Okay, so tomorrow we'll be completing, I mean the next class will be completing what all to be covered with respect to the numpy functionalities. So if you have any doubts for today, please let me know. So here we are importing the warnings, and we are importing numpy as np, and I'm calling warnings dot filter warnings ignore. Okay, we are ignoring the warnings. Then we are setting the print option. The print options, when I say threshold is equal to 100, mean to say that just print the values till 100. I'm putting the threshold there. Okay, so I'm asking for the numpy version. It's 1.1.9.2. Okay, and I'm creating an empty array. Whenever I'm creating an empty array means to say that we can't leave a space blank, so the random numbers will be filled in an empty array. So I'm telling the data type is int. np.empty is the syntax. 2 comma 2 is number of the number of columns, and the syntax and the data type is int. That makes sense. Okay, so I saw the shape. The shape is 2 comma 2. The size is 4. So now you must understand, when I say the size is 4, it is an integer data type, right? Okay, so it's giving us size as 4. Great. Okay, I'm creating one more array, one more syntax like that. When I say np.array, again it's an array with empty braces, which means to say that there is no values inside it. Okay, np.array of 1 comma 2, right? When I'm creating np.array of 1 comma 2, that is, it is having two values 1 and 2. I'm writing a simple function to check which array is empty. Okay, so we're using the if and else. Just a revision for you people to understand how the if else will work and how the functions can be created. Okay, then check elements of count. We are trying to check what are the elements which is present, how many elements is present, what is the count of the elements. That's again we have created a function called as get element. get element. Okay, then we have C and D, we have just created it. And we have np dot a range of 4 comma 12. Now you must understand, when I say np dot a range of 4 comma 12, we are creating elements from 4 to 11, say 4 5 6 7 8 9 10 11, right? So we have just created an element. So what happens here is we can ask the shape of it, which is a dot shape. It says 8 comma nothing. 8 comma nothing mean to say that when there is no number, it always assumes that, like, its number is 1. Okay, so now we have np dot a range of 12 comma 30 comma 3. Okay, here we have number is starting from 12 and it's going till 30. Every time the gap is 3, so it is 12 15 18 21, like that we get a series of numbers. This is all about this. Then I asked about the shape. The shape, it says it's 6 commas, it's 6 rows with only one column. I can reshape it. Okay, if you want I can reshape it, which I'll be seeing, which we know already how to reshape it. Okay, we can do that later. Also, we have any reshape option here? Okay, yes, we have to reshape here itself. You see dot reshape of 2 comma 3. Okay, it was just a single dimensional array like this. After reshaping, I changed this to 2 rows and 3 columns. Okay, this was about the reshape function. Okay, now when we will understand, like we'll be asking random questions even in the quiz and in the assignment. At that time you should be capable enough to answer any questions, so please concentrate. And we are given np dot random dot random. Random dot random will generate the random numbers in terms of the value between zeros and ones. But we have random dot rand int. This rand int will generate the random integer numbers, which is like around 10. Okay, size is equal to 6. What is 10? 10 mean to say that I require the decimal number. Size is equal to 6 mean to say that like I require 6 numbers. So similarly, I do random dot random np dot random dot rand int 2, mean to say I'm looking for the binary number. Size is equal to them. If you ask me, so what all, which are different types of you know expressions present? Like it can be a decimal or it can be a binary. Okay, so what can be the base? So we have a lot of things like that. We can go to np dot random dot rand int, see the documentation, you will understand. Okay, so we are just doing this. We got A, which is having 6 numbers of decimal data type. So if I print B, you'll be getting the binary values. That's it. Okay, so similarly we saw the same and we sized it. Okay, we told the size what I expect is 2 comma 3. So np dot random dot random of 10 and size is equal to 2 comma 3, and we reshaped it. Okay, so reshaped in terms of automatically we can reshape, even automatically inside the function only we can define the size, or else you define the array, and if you want to reshape it later, you can use the reshape function. Okay, so this is the option what we learned. This as all we discussed already. And I told you about the data type. Okay, the data type in terms of we discussed already. So what happens when I give, now we have Toronto, Montreal and New York. Okay, so all these are string, so automatically the output would be a string character. Now if you insert any integer over here, so the integer will also be converted to string. This concept is called as upcasting, that is converting from lower data type to higher data type automatically is called as upcasting, and we discussed it already. And converting from higher data type to lower data type is called as downcasting. Okay, so downcasting has to be explicitly done. Okay, but when we say an array is a homogeneous values, right? So when I say homogeneous value, every value must be of the same data type, so everything will be converted to string, right? So this is what we understood. If you ask me what is this u8, it is undefined. Okay, it is undefined, I mean unsigned value, right? Unsigned value in terms of there is no signed bit here. Okay, again it's completely with respect to programming. Don't worry about the what is unsigned, what is signed and all. It's not time for us to discuss those things, right? So now we have something like d type is equal to string. I can explicitly tell the data type of the variable like this. We know already we're creating an array. That is what we saw. Okay, now I created np dot arrange. Okay, the arrange values, and I'm telling the threshold. I'm not fixing it now. I'm not fixing the threshold. I say threshold is equal to sys dot max size, right? So np dot arrange of 10,000, I'm getting the 10,000 values from 0 to 9,999. Okay, I don't want to print all the values. If you don't want to print all the values, just print x, since you have a threshold. Okay, since you have a threshold, it says like something like I'm started from 0 and I'm going till 9999. It just shows like that. Okay, but if you want to say no boss, I want to see all the values, then increase your threshold. Threshold is equal to this dot max size. But usually we never put the threshold to max size. We limit our threshold, because while reading in data science we read billions of rows, right? We read millions and billions of rows. What happens if I give a threshold is equal to max size? Your complete if you're working on Jupyter notebook, let me assume the complete like browser files will be filled only with the values, where you feel very we can't even feel like seeing the values, because all the values has been displayed over there and we don't even get space to understand what is happening. right? So usually we don't do that. I want you people to keep in mind whenever we give the threshold as this dot max size, just to show you it is possible. I'm showing like this, but never we do this dot max size. Always we keep a threshold. By default, threshold value is somewhere around 100. We just keep the same. Okay, so before setting options you get something like this, but after setting the options you get all the values. This is about the threshold size, right? Now here what we are doing now is I'm creating np dot as array. I'm creating np dot array, right? And I say 1 2 3 4 5 6. Okay, then I'm trying to convert it to csv file. Very simple. Okay, I try to say save it as text. We have a function called as save text, and I'm converting it to abc.csv. Okay, for what you want to do abc.csv. Okay, this a I want to convert to abc.csv. What's the delimiter? Delimiter is comma. Okay, you know csv mean to say comma separated values. So I say delimiter is equal to comma, and I say np.saveText. Okay, now I'll just run this. If you can understand, here there will be a file by name abc.csv. That's it. Okay, if you download it, it's nothing but a csv file. The csv file. Okay, the csv file, right? So how to how to exactly save the file? abc.csv. If you ask me, Vinay, can we do different extensions for that matter? Of course, yes. Okay, it can be text file. We'll be seeing down the line, don't worry. We can save the text file, or sometimes of course the if it is something like xml documentations, we can also do it a json file. But for numpy, usually it is a csv, right? Okay, because it is a series of array. It is having the data in terms of rows and columns. When the data is in terms of rows and columns, something like a structured way, so usually we prefer it as csv. We can't use any xml or json. People who are very new to xml and json files, please don't worry. Okay, those are the different file extensions, right? But usually whenever we have an array, I can convert the array component into the csv file using like this np.saveText. Okay, this command automatically will save the data to csv file, provided you must give the delimiter. If you ask me what is the other delimiters which is present, of course I always tell save text, open it, open the function, you'll get to know what are different delimiters which is present for save text. Okay, so let me know if you have any questions with this. So now we are seeing some advanced functions. Okay, see, from now on things goes very interesting, because we'll be seeing lot of beautiful functions which is present in numpy. Okay, and always keep in mind that we don't need to by heart. Okay, you must not feel that when you're doing a lot of functions we're not able to recap the functions. So please don't worry, it comes by practice. Okay, one thing. Secondly, you must know yes, something can be done like this in numpy, right? Okay, you can just now keep in your mind, and later you can browse for the function. That's always okay. Okay, but it's not like whatever we learned till now was very easy to understand, because it was np.zeros, np.ones, np.array, np.namespace. Okay, we learned all these functions. It was very straightforward. Okay, but now what I do is, okay, it is something with respect to a bit advanced level of how to use the numpy functionalities. So if you don't understand, you must ask me. Okay, if you see no, like I can't remember these functions, don't worry, maintain a cheat sheet. Okay, and revise it. Okay, that's the only way for this. Okay, because these are the advanced functionalities. Okay, where I'm trying to show you the applications of numpy. Okay, what all can be done in real time. Okay, so please maintain a notes. Okay, it's always good. I always suggest to people to maintain a notes. Okay, because just listening to the class and seeing the videos doesn't help you. Okay, I want you people to always keep a notes and keep on updating the whatever I say in the notes, so that it becomes a revision for you at least once a day for 55 to 10 days. Okay, revise these functions. Okay, trust me, you'll surely remember these functions. Okay, I'm very sure after my class you people will be very confident to work on the concepts. I'm pretty sure about it. I can guarantee you on this. But what happens is, if you want to remember for a long time, yes, you must always revise it. Okay, okay, so I'm creating get the nth column of an array, mean to say that I've created an array 1 2 3 4 5 6. Now I want to get some particular column. Okay, this is called as a concept of slicing and dicing, right? I want to get some particular column. See, we have 1 2 3 4 1 2 3 4 5 6. So what exactly is happening here is, I have the actual array 1 2 3 4 5 6. Now I say I request 0th column. I can give something like this: 0th column, x of is 2 comma 0. When I say is 2 comma 0, mean to say that, okay, when I say is 2 comma 0, it mean to say that all the rows I want, and I want 0th column. Okay, all the rows I want 0th column. So it will say, oh, you require all the rows. So first row, second row, third row, and 0th column. So it is 135. Okay. Now you say I require all the rows who are first column. So that is 246 is the output. You say I want the all the rows, I mean all the columns, what only the first row. So it is nothing but 1 comma is 2. So what you need to understand here, you need to understand that there is something like comma. Okay, there is something like a brace, we have something like comma. Here there are two options. Okay, when I say there are two options after the comma, okay, whatever comes before comma is for the rows, whatever comes after the comma is for columns. Okay, this concept is called as slicing and dicing, which will be continued even in pandas. Okay, this is how we extract the data values, right? So here when I give something like is 2, it means to say that all the values. So comma 1 mean to say that all the rows first column. When I say something like 1 comma is 2 mean to say one row and all the columns. So this is how we start extracting the data. Okay, so this is how we start extracting the data. And we'll go for the next function now. We'll go for the next function. As I told you, okay, you might feel we are doing something, which is something of theoretical or something like, no, it's not theoretical. Okay, theoretical in terms of, I understand it's a dry concept. Okay, but lot of things we'll be doing it as a, we are doing like a bits of papers. That's it. Okay, we are just doing in a bits, very bits. These bits will be combined together, and we will be creating a beautiful model, machine learning model later. Okay, but all this will be taken in chunks later. That's it. Okay, this is all about it. We'll go for the next function. So I'm creating something called as np.matrix. Okay, so if you ask me like, what is it array and what is a matrix? See, there's no much difference between array and matrix. Okay, we will see that. So what happens with the major difference? So if you ask
Hello,
me,
sir.
yeah,
So
any questions?
Sorry for disturb.
Yeah,
Sir, in this zeroth x of is to comma 0 is there, no?
yes,
In above function.
correct.
Is display every zeroth position. Like we are giving 3-dimension matrix.
Okay, no, that's fine.
It,
That's fine.
it gives every zeroth position of
Yeah,
three
yeah,
different
it gives us,
column.
when I say something like 1 2 3 4 5 6, it is living like x is 2 comma 0 mean to say that I require all the rows. I told you whatever comes before comma is for the rows. I require all the rows, so I'm giving is 2, and I require 0th column, so I'm giving 0. Okay, so what it will give you, 1 2 3 4 5 6, it will give you the 0th column, it will give you 1 3 and 5.
Okay, fine.
Okay,
If I give one, it
then we'll
is
be getting
2
2
4.
4 6. Yes, correct.
Yeah. Thank you, sir.
Okay,
Vinay, can I see the just sorry on the same example above?
okay.
Please, can I see the second example where you're printing backslash nx? How does the output looks like?
No, it's like I'm trying to. I want you to understand the output as it is, no? Because here when I say z of x is to 1, I want it to print like this. Where it I say x is to 1. Okay, see, I want to print something like this. X is to 1. Okay, so I want to print as it is. So what's the function I use and what is the output? That is the reason I'm using x is to comma 1, just to show you people what is the command
Oh,
I'm executing. That's it.
okay.
Okay, slash and mean to say I'm entering the new line. Simple.
Okay.
Okay. Fine.
Mhm.
Okay,
Yes.
so here we are coming to something with respect to matrix. Okay, so and here what happens is the same functionality I'm doing in a different way. I'll try to show you what is happening. So this is the original numpy array which of the shape 3 comma 4. Okay, and I'm doing np dot reshape of a comma minus 1. Okay, you must understand that when I say reshape, okay, reshape option, I can reshape it to something like I have 3 rows and 4 columns. Now it can be reshaped to 4 rows 3 columns, quite possible. I want you to understand, quite possible to do that. But what I'm doing now is I'm doing nv dot reshape of a comma minus 1. When I do a comma minus 1, automatically irrespective of any dimension, it makes to a single dimension array like this. Okay, this is a single command which is called as a comma minus 1. Okay, so a comma minus 1 mean to say that irrespective of how many number of rows, how many number of columns is there, the complete it will be giving you the one row. It will be like this, 1 row and 12 column. Okay, so np dot reshape of a comma 1 comma minus 1. Okay, what this will do? Okay, the same example I'm showing you, the different ways how we can reshape the array. Okay, 1 comma minus 1 mean to say that I require one row, minus 1 mean to say I'll just bring it back to the single, in a single dimension. That's what it means to say. So np dot reshape of a comma minus 1 is same as np dot reshape of a of 1 comma minus 1. Okay, this can also
Vinay,
be
I'm not
done.
following this. Why do we have to say -1? What would happen if we say
It's
just
a
one?
single command. We call it as a lazy loading. Okay, rather than giving us np dot reshape of something like 1 row comma 12, 1 comma 12. I can just give np dot reshape of a comma -1. It is same as the same as the giving 1 comma 12. -1 automatically makes sure that it will give you the single dimension, which is something like 1 row and all the columns. That's it. Okay, when I say 1 comma -1, automatically irrespective of the matrix dimension, it will give you the single row. That's it. Shortcut to define single row. I mean, you got it. See, you have something like 1 2 3 4 5 6 7 8 10 11 12 and 21, right? So it is having how many, like 4 rows and 3 rows and 4 columns. I don't require 3 rows and 4 columns, so I require only single row. So what you can do is you can just say np dot reshape of a comma -1. That's it. You got it. Okay, when I
But
do
why
reshape
can't I say 1, 1? I'm not.
1 comma 1 we to say it becomes a shape redimension. No, if you say 1 comma 1, what happens? You are telling that you want to reshape it to 1 row and 1 column. If I say something like np dot reshape 1 comma 1, you are telling that it is actually it is having
Oh, okay,
3
got
rows
it.
and 4, yeah, 3 rows and 4 columns. If you say 1 comma 1, you are making it 1 row and 1 column, so there's a data loss. It shows an error.
Yeah.
Got it.
Okay.
Okay, fine. So similarly, we are doing something like 2 comma -1. 2 comma -1 in terms of I'm making it as 2 rows and rest all the columns automatically get adjusted. Okay, see, in terms of you can just define the number of rows, automatically the column gets adjusted. It's not the case where, let me say that I have something like a huge data set, and you say that I require something with respect to 50 rows, and I'm not worried about the columns. You just say that I want the data in 50 rows. You just give 50 comma -1, so number of columns will automatically get adjusted. That's what I want you to understand. In this case also, I gave something like 1 comma -1. So 1, you are telling that 1 row. So the number of columns is automatically getting adjusted to -1. Mean to say that it is you are telling 1 row, the number of columns is automatically defined. You are telling 2 rows, the number of columns is automatically defined. Similarly, you are telling 3 rows, the number of columns is automatically defined. That's it. Can you see here? 4 rows, columns automatically defined. Okay, so -1 has that capability to arrange the data given any number of rows. Everyone followed with this? Any concerns with this? No? Yes or no?
No, sir.
Good to. Right, thank you. So now I'm creating something like np.random.random of 10. So I'm having a series of numbers, which is random numbers of 10 different numbers, and original array I'm printing. And after setting the precision, what is the precision? You know precision, right? Okay, precision is setting the number of digits. Okay, where we see something like 0.07, 0.36, 0.45. I'm just setting the precision. Okay, so in the set print options, we have something like precision. So I can set the precision option also. Okay, usually the default precision is 8. So we'll be having the 8 numbers. We can see here 1 2 3 4 5 6 7 8. So after the decimal value, the 8 numbers is the usual precision what has been maintained by print options, but you can reduce the precision to 2. Okay, those are very simple commands, but yes, you have to keep all this in your mind. Okay, yes, we can do that. Then someone asks you like, is that we can round off the precisions? Yes, we can do something like print options. And one more thing is we are not rounding off. We'll be seeing the function to round off, how to round off the function or round off the values. I'm just reducing the precision. Okay, so reducing the precision in terms of, by default the precision is 8, but we have a function called a set precision, set print options. Using set print option, we can reduce the precision to 2. Okay, so you'll be getting only 2 values after the decimal places. Okay. Next function what we'll be doing now is I have something like random.randint, and I'm generating 0 comma 10 comma 3 comma 3. Let us see what is the output here. Okay, so here I'm generated 0 comma 10 comma 3 comma 3. What it means to say, it means to say that okay, start from 0, end at 10, and I require 3 comma 3. Okay, so I require random integers. Correct. So you got to know something like 0, start from 0 and the decimal value. Okay, and 3 comma 3. Right, so you will just like how we saw the random integers previously, the randint is used to generate the random integers. I'm just giving a revision of the same, provided here what I'm telling it here is I want it from 0. Okay, started from 0. So let me say that I can give something like 3. Let's see what happens. Okay, so what happens here? Can you observe the change? I'll put it as let me say 7. I'll put it as 4. Can you see it? Tell me what's the thing?
That starts like within the range 4 to 10, like
No, because random int, the first option is giving telling the decimal place. It is telling like 10 is a decimal value, 3, 3 is a shape. When I say 4, when I say something, let me say I have 8. Not 8. Let me say 6. What is happening? I'll put. I want you to observe 3. I'll put 1.
So starts with 3.
No, it's not starting with 1. If you say generate a random integer, but you require one number for sure, which number? That is 1, then you can give like this. When you generate a random integers, 1 has to be there. Got it? When I say 1, 1 will be there for sure. The random integers will be generated, 1 will be there for sure. Okay, I give something like 5. 5 will be there for sure. Here let me say I have 7, 7, 6, 8, 8, 6, 7, 6, 5. There is no 4. So when I say next time you generate a random number, make sure 4 is there. Am I with you? Yes?
Okay.
Yes, sir.
Yeah, got it.
See, these are very small functions, okay, but it's not so much a big concept to explain again. But I don't want to skip. That's what I always say. I don't want to skip any of the concept which we'll be doing, which we'll be covering later, because at that time I don't want you people to feel, oh, we didn't do this. So that's the reason we are just revising everything. And here we have np.array. We have 2, 3, 4, 5, 6. So I'm finding the inverse. Okay, so inverse. So how to find the matrix inverse? If you know, good. If you don't know, don't worry. We'll just revise few concepts there. Okay, how to do matrix inverse we'll do, and that is not a big deal for us. If you want to really do the inverse of a matrix using Python, they need to write quite a long, around 8 to 10 lines of code to do that using Python list. Okay, or else using some basic Python. But this is because you're working on the Numpy package. Numpy package implicitly has a library called as linear algebra. So using linear algebra dot inverse of b, automatically you'll be getting the inverse of a matrix. A single line. Using a single line, we can find out the inverse of a matrix. Why do we want to find the inverse of a matrix? Okay, applications will see it. Don't worry. Okay, so a lot of things even, and one more important thing is whenever we define the algorithms in a later part, right? That algorithms we don't write the algorithm from the scratch. Okay, I want you to understand. Okay, there are packages which is there. You will be using those packages. In the packages internally, there are a lot of mathematical operations which should be done. There they'll be using something like this. Okay, so we don't get a chance to code the algorithm. No, you will get a chance. If you want, you can write. But why do we want to do that? No, there's already a package which is providing the particular algorithm. Just use it. So what will be there in the algorithm? There's a mathematical concepts behind that algorithm. In those mathematical concepts, you'll be using those functions like this, Numpy, okay, linear algebra, all those things. So we never use this. We also use this. Okay, we also use this, but we will see. It's not that when writing the algorithms, but in a different way. Okay, we will see that how it will be done. But on the later phases, let me say you are around 3 to 4 years data scientist or data science engineer. After 4 5 years, you'll be directly given an option to work in the R&D team, where you'll be involved to write an algorithm, given a paper, given a research paper, given a publication paper. You want to write the algorithm on your own by seeing some papers. That time you want to work on the core mathematics. You will be using a lot of Numpy and Panda packages functionalities there, because we need to convert the theoretical mathematical calculations to the programming. That time we'll be using this. Okay, but it's not that we won't be using all this when we do. There are cases, but rare. There are rare cases how we'll be using all this. Okay, the next functionality is Numpy compare. Okay, this is interesting.
Hello,
again. Yeah.
Hello,
Yeah.
sir.
Yes, go ahead.
Sir, in random.randint, I have one doubt.
You have one doubt.
Yes. Can you please type this code, sir?
Yes.
np.random.randint.
Okay.
Of 1 comma square bracket 3 comma 5 comma 10 square bracket close and
1 comma 4 comma 5 comma 3 comma 10.
That is in square bracket 4 5 3 10.
Yeah, we are given 1 4 5 3 10. It shows something. What?
Yeah, that is in
low is greater
bracket,
than or
sir.
equal to high. Okay. Square brackets.
Yeah.
Why square brackets?
Sir, that is in I saw it in this one only, sir. After
You want to here you want to give a square bracket, you mean to say?
no one comma, after one comma, that is all in square bracket. One comma, square bracket open.
You mean to say 1 comma,
Yeah,
okay, square bracket open,
square bracket open, and next numbers 3, 5, 10, anything.
3 comma 5 comma 10, okay,
10. Square bracket close, normal bracket close.
like this.
Yes, sir. Here is no numbers, sir, here after closing.
So you don't want to give any numbers here?
Yeah, no.
I think some bracket need to be closed. Yes, one more bracket.
Here starting, sir, in randint.
What is happening here?
There is two. Yeah.
So it says not supported list in the int.
No, sir. Here I seen it is displaying. But,
Okay, do like
what
Abhishek.
is happening,
You
I
can
don't know.
Abhishek, you can send me in the chat box. Okay, I'll surely do it.
Yeah.
Okay.
Yeah, fine.
Okay, please send me those snapshots. Okay, don't worry about it. Okay, so fine. This is about the core functionalities where we were there in compare. Beautiful. This is again a beautiful function compare. Let's have a small minute of break. We'll connect immediately because we want to complete NumPy today. Okay, we'll connect immediately and we'll continue with this. I'll be sending you ID and the password. Thank you. This NumPy comparisons, right? So I have created np.arange of 12.reshape of 3 comma 4. So now you must understand. Okay, reshape array range of 12 mean to say that I'm expecting the numbers from 0 to 11, 3 rows and 4 columns. Makes sense. And I'm writing a code here telling it as a less than 6. Wherever the value of a is less than 6, just print that. So I'll do this and just run. So wherever the value of a is less than 6, you're getting true there, or else you'll be getting the false. If you ask me, okay, what is the use case? Lot of use cases, right? I want to check whether the account balance is less than whoever account balance is less than 10,000. Just give those values. So whenever now later while doing slicing and dicing, I just extract the values whose data is true and I'll pull them out. So simple comparison command. Okay, so I have created an array and I say a less than 6. When I say a less than 6, you'll be getting wherever it is true, you'll be getting here as true, which has been printed. Okay, simple comparison. Like now we have a beautiful command called as flip. Okay, flip up. Okay, so what is the flip up? What it will do? Now I have created np.arange of 4.reshape of 2 comma 2. So it will be getting like 0 1 2 3. Okay, so before and after I'll show you what flip will do. Flip. Okay, just show this. What is it doing? It is just pushing the second row to first row and first row to second row. Can you see this?
Swapping. Yeah.
Yes, correct. Okay, and there are different things like I can flip in terms of columns also. I can flip in terms of I can rotate. We'll be seeing it. We'll be seeing all those things. Okay, next one I have something like this. Okay, I have one more function which I have written np.arange or reshape of 2 comma 5 print before and print a. Okay, so print before in terms of 0 1 2 3 4 5 6 7 8 9, and I told np.flip r. Okay, here what is the function? Here the function is flip ud. Okay, here the function is flip ud. Here I'm using something like flip r. Okay, flip r is flipping horizontally. Okay, what it will happen? What happens here is it is 4 3 2 1 0. Horizontally it just flaps. Okay, like it just flips from this position to this position. Horizontal flipping, that is flip r. If you want to you want to make it from lower to upper, upper to lower, in that case you can use something like flip ud. You're following? Yes.
Yes, sir.
Can you observe the changes? I want you.
Yes, sir.
Here the output is all on observations. Okay, it's not nothing on a concept. Don't worry, it's not a big concept. It's just like observation. Keep on observing. Function output. Function output. That's it. We are doing a lot of functions in the output here. That's it. Okay. So let us take one more scenario here where I have given flip. I just given flip. Okay, not flip ud or flip r. I just given flip. Okay, so when I just give flip, before it is 0, 1, 2, 3, 4, 5, 7, 8, 9. After flip, it completely rotates. It says 9, 8, 7, 6, 5, 9, below row to upper, and it reverses the number. And above row below, it reverses the number. This is with respect to just a flip. Okay, so we saw three things. One is flip UD, other one is flip R, and other one is flip. Following? Yes? Observing the output? Making sense?
So,
Yes,
Vinay,
yes.
I have a question here. The
Yes.
function was flip LR. Is it like flipping left to right?
Yes.
And do we have another one also?
We saw three, right? One was a flip UD. You can see this? Flip UD.
Yeah, UD
Yeah, other one is flip
is up and
R.
down, and
Yeah,
then this
flip
is
R. This
horizontally
is just a
left to
flip.
right, I think.
Yes. Yes. Okay, left to right, just a simple flip.
What's
Okay.
the
Difference is
difference between?
here when I say flip left to right, the rows are not getting flipped. Only the values are getting flipped. 4, 3, 2, 1, 0, 0, 1, 2, 3, 4 was there. 4, 3, 2, 1, 0 is happening. Here 5, 6, 7, 8, 9 was there. Here 9, 8, 7, 6, 5 is happening. But in the case of below flip, the rows are getting interchanged.
Oh, okay.
Okay.
Yeah.
Fine.
So basically, in that case, like flip is like it is having properties of
Both.
both flip UD and flip
Yeah.
LR.
Yes, correct.
Yeah, up, down, and LR, both.
Yes, you can understand like that. No worries. Okay, so now I have an array of numbers with a range, and I'm trying to convert it to a list, right? I'm trying to convert it to a list. I want you to understand. Okay, so here I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it was an array. I can convert an array to list. If you ask me, why do we want to convert an array to list? Very rare case. We never do it. Okay, we never usually convert array to list, but in the extreme cases, we can convert array to list. Okay, if there is an option, I say yes, there is an option. We can convert an array to list. But usually what we do is we try to convert list to array, because when we convert a list to array, we'll be getting a lot of functions to do. But array to list is of usually it's of not a right kind to do, because list doesn't have much functionalities. But can we convert an array to list? Yes, we can convert. That's what I have shown here. Okay, I just showed how to convert array to list. What is this type of A? I'm telling you, it is a array. A type of A is an array. Type of A of 0, again what it is. Okay, it is a numpy ND array. Okay, then similar case, before it is list, and finally you're getting it as int. What is that you're getting it as int? Because I am slicing it. I want you to understand A of 0 to 0 mean to say that I'm getting 0th row, 0th column. I'm getting 0. Right, 0 to 0 column is 0. If I am taking only one particular value and I ask for the data type of it, you will be not getting it as array, rather you will be getting the data type behind it, which is an integer. Correct? No? Are you with me? Yes? Correct, you are getting it as integer.
Yes.
Similarly,
Yes,
in
sir.
this case also, b of 0 comma 0, even though it is a list, when I do b of 0 0 and the data type of it, it is an integer. If you ask me, Vinay, how come you are getting only int here, there you are getting numpy int 32? Numpy int 32 is a implicit data structure present by numpy, so it is getting as numpy int 32. But when you convert it to list, by default it is an integer data type. Okay? Just things to observe. Okay, so just the things to observe, right? So I'm just trying to extract the values, type of the data type of what A it is, just understanding of what converted array to list and the data type behind it. This is a beautiful function, numpy where. Okay, numpy where is a beautiful function. Okay, I'll show you. So np.arange of array shape of 2 comma 4. I am assuming that you people are taking the notes. Okay, please take the notes. Okay, so np.arange of 8.reshape of 2 comma 4, print before a, print a, and print after. Now, what is happening here? Oh, np dot where a less than 4, 0 comma 20. Can you observe what is there? Anyone?
Yes.
Let's see who can answer.
Basically, it is saying that like if A is less than 4, right? Make it 0. Otherwise, make it 20.
Fantastic,
Replace.
good. Okay, so np dot wherever a is less than 4, make it as 0, else make it as 20. Simple. Okay, where clause. Okay, so like how we have a where condition update with the both both different commands, where and update can be done in a single function where give the values. Okay, yes, following.
Yes, sir.
Yeah, good.
Yes, sir.
So given the assignment at that time, you must be very much sure. See, those are different functions. See, we are trying to analyze different functions. As I told you before starting this session only, it's not that we are by hearting or okay. I mean, we are not able to remember. I do agree. We can't remember all the functions at a single shot. Okay, so just keep on revising the functions, so you'll surely get it one day. Okay, at least not even for a long time. At least 3 to 4 days. If you just revise functions, you'll get to know what are different functionalities which is present, so that it will be helping you for the interviews, the first perspective. Secondly, for while working on the programming, okay, which is very important to understand. Good to go, right? So let me say I created one more name here. Here I have taken two conditions. I say np dot where a is greater than 3 and a is less than 7. If a is greater than c and a is less than 7, 0 comma 20, the same thing, right? Here I'm checking the two conditions. One is a must be greater than 3 and a must be greater than 7, then put 0, else put 20. Yes, are you following?
Yes, when I have a question.
Yes.
In the where function, can we use the multiple data structures like array and list?
Array and list in terms of where function, like you mean to say here you don't want to print I mean here I given a numpy array. Can I give it a list is what you want to ask?
Yeah. If I
No,
can apply one condition to array and another condition to
no,
list.
because the where condition works for the arrays. Okay,
Okay.
it is for n dimension array only. So it's no list
Okay.
comparison. Okay,
Okay.
fine. So this is about checking for the multiple conditions, right? And we are converting the list to array. This is quite possible. Okay, what a single command where we have a is a list. A list is 0 comma 1 comma 2, and I'm converting this list to array, np dot array of a. So simple, right? So I just converted to 0 1 2 was array. Like it is also 0 1 2 only. Okay, it is a list, but in the next case it is an array. Okay, and why did you convert to array? I told you, lot of functionalities which is there. Okay, simple. Okay, list to rumper SBD type, and I can also convert list to array with explicit data type which has been given. When I'm converting the list element here, I can convert it to an array by giving the particular data type as float. Okay, this can also be given. Okay, this can also be given to us. Makes sense. Okay, now we have np.random.random. I want you to follow this. np.random.random integers 0 comma 10 comma 10. np.random.random 0 comma 10 comma 10. I have a and b, and I have something like intersect command. Intersect one dimension a comma b, which is having the intersect how it will work, right? So np dot intersect one dimensional, which I can give a comma b, so that you are getting the common values which is present in a and common values which is present in b. Okay, that is with respect to intersect commands, right? So I'm trying to tell very basic and very important functions. Okay, there are more than 250 functions present in numpy alone. 250 functions present in numpy. Okay, why people choose Python is full of packages. Python is full of functionalities where it will ease the developers effort. Like it's like we don't want to put a lot of effort in coding. That is the reason we use Python. So if you ask me, we are doing so many functions. Is there any other functions apart from this? Yes, there are a lot of other functions, but we don't see all those functions because it's rarely used. It depends on a scenario. We can try to Google it and we'll get the answer. We can replace it. That's always there. Okay, but I try to identify which are at least important to some extent. Okay, and that we have covered it. And the first session what we covered was very important. Okay, what we covered in first session. Now what we are doing is, it is very interesting. It is important to remember this. You can make a note, just revise it so that you understand when you get a scenario, you must use these functionalities. That's it. Okay, so one functionality there is intersect. Is there union? There is a union also. Okay, so I mean it is there. You can't see, like, so what is the syntax again? So help, take the help syntax and keep on doing. If I want to continue all the functions in numpy, we have separate course for numpy itself. Okay, I mean it's something like that. Okay, we can take a complete course for numpy, but it's of not really valid because we don't learn. It's just like learning the syntax and executing it. It's not nothing like a concept, right? As you can see, everyone here, I'm just learning the syntax here, nothing more than that. Okay, so actually I took the important functions which I have used while coding, and I'm executing all those things. That's it. Okay, so next function here is np dot datetime. Okay, a datetime of day. See, this is also possible. Okay, np dot datetime, and I'm given it as today. Okay, so print today np dot date time today plus np dot time delta of 64 2 comma 2. I'm trying to do date addition. See how does it look today, after 2 days, after 3 days, after 1 week, after 10 weeks. This is also possible in NumPy. Okay, simple command. Okay, simple command. I'm getting the today's date and I'm trying to extend by 1 week. So very simple. np dot time delta 64. Okay, 1 comma w. If you ask me why are using time delta 64, it's a syntax. Okay, time delta 64 is like whenever you want to do addition of the dates, I'll be using this. Okay, so I'm getting the actual date plus I'm adding 1 week for it. So it will say for 1 week from now, this is what is happening. Okay, so after 10 weeks, give 10 weeks. Okay, if you want to get in terms of days, yes, we get in terms of days. Vinay, can we do in terms of time with respect to hours and seconds? That is also possible. Okay, don't worry about it. It is also possible. Okay, so mean to say that date actions can also be done in NumPy. Are you following? Am I with you?
Hello, sir.
Following, Pooja?
Yes, Vinay. Thank
Okay,
you.
good.
Hello, sir.
Sahana? Yes, Abhi?
Sir, in this question, in this
Yes, sir.
example, we are without using datetime module, importing datetime.
Yes.
Without using datetime,
Without
it is
using
displayed.
NumPy, using date time.
Okay. With
Okay.
using NumPy, we are
Using
displaying
NumPy, using
datetime.
this. Yes. Okay. We have
But not
something like
yeah,
datetime package is there. It is not a NumPy package. It is the Python package. Using that
yeah.
also we can do. But things are very easy using NumPy.
Okay, fine.
Okay. In Python also
Yeah.
we can do. That's the reason. So people who learn Python very well, they would have thought, oh, this we are doing in 3 lines of code. I don't know. People who are good in Python would have understood. By doing the date addition, we need to write 3 lines of code. But in Python, it's a single line. That's it. Okay. Next I have taken with the between the dates. I want a series of dates. Okay, so I given something like np.arange for dates. Yes, arange for dates, because arange have an option to give data type. No, right? I'm giving an option as data type. I said d type is equal to date time of 64d. Okay, and I'm saying that what is the difference between the two dates, difference between 2 months, that can also be given here. Okay, so np.arange, getting a series of dates, right, between 2 months, 2020-09 and 2020-10, what all the dates we are getting in here. Okay, in the above case, the same, the series of dates between two dates. So arange can also be used to get the dates. Yes, arange can be used to get the dates. Vinay, you didn't tell us. I don't know. The data type option has been given. You can give any data type. So what all different data types present? Okay. Please see the documentation of arange. You'll get to know there are different data types what we can give in arange. Okay. It's all about it. And sort. Okay, we have a sort function. Okay, np.arange. Okay, I've given np.random of 5 and I given a sort function a.sort. So before it is in the non-sorted order. In the below case, it is like, yeah, it is like unsorted. It's a sorted order here. So it is just sorting. If you ask me, Vinay, can we sort it in a descending order? It's quite possible. We can see the function of sort. This says ascending is equal to false, descending is equal to true. So keep that sort function. You can sort it in a descending order also. We'll be seeing the see NumPy is only like this. We have brother of NumPy who is something called as pandas. Okay, it is beautiful. Okay, it is beautiful. Pandas is much more beautiful, and we can do a lot of other things in pandas also. Okay, why people learn these packages is the effort of the programmers are really reduced a lot. Even on my personal experience, I'm telling you. Okay, when I was learning NumPy, I was very good at Python. Okay, I was very good at Python. Okay, I really, when I was to code something for 1 hour of time, I learned NumPy very well. I reduced it to 15 minutes to 20 minutes. Okay, that's what the time duration what I reduced because I learned NumPy and pandas very well. Okay, with beautiful package, I'm telling you, spend a lot of time. You love this, you love working on NumPy and pandas. Okay, and this is with respect to sort functions. Okay, simple sort function what we saw. And see, this is what I have used, so this is the reason I'm just telling you all this. We have the next one called as nearest element in the array. Finding the nearest element in the array. Okay, this is bit tricky. Okay, I'll just tell you what it is. We have something np dot a range of 10 comma 60 comma 7. Okay, so I'm getting a range of 10 comma 67 7, mean to say that I'm getting the values from 10 to 60 at the gap of 7 numbers. So 10, 17, 24, that you are getting it. Okay, so I'm trying to search something like b is equal to 23. Okay, we have some function called as flat. Okay, we have some function called as flat. Okay, the flat function, what it will do is it will try to actually iterate. It will try to iterate for every numbers present inside the array. Okay, so what I'm doing is I say np dot abs. Abs means to say absolute value. Okay, I say np dot absolute value of a minus b dot argmin. Argmin will tell you the nearest value of the given number. Okay, a minus b, what is a? Okay, a is series of numbers which is 10. 10 minus 23. Okay, then 17 minus 23. I keep on doing a b, the 24 minus 23. Abs mean to say it is absolute value, mean to say it is removing the negative. ABS will remove the negative component of it. So np.abs.argmin. Argmin mean to say that I'm trying to get the nearest value for 23 in the given number. It says it is 24. So what this flat will do? Flat will use to iterate the objects. I have 10, 10, 17, 24, 31, 38, 45, 52, right? I want all the numbers, so I'll use flat. Okay, a minus b is actual subtraction. Argmin will give you the nearest value. Okay, so np dot absolute what it will do? Abs will remove the negative numbers. For example, when I subtract 10 minus 23, it is a negative value. Since you're using abs, the negative value has been removed. Okay, then here I'm printing something like this: element nearby slash b slash c. This is a format. This is called a string formatting. String formatting in terms of I'm just giving in the flower bracket b, flower bracket c. This flower bracket b, flower bracket c provided with f, mean to say it will trying to find out the value which is present inside b, the value present inside c. Usually what happens, whatever we give in the single quotes comes as it is, no, but since you're using f here, it is string formatting. I will repeat, it is string formatting, where even though you are giving inside the single quotes, you are given a flower bracket inside it. It will try to look the value which is present inside b and the value which is present inside c. Am I with you? You got it? Yes or no?
Yes, Vinay.
Yes, sir.
Great.
Yes,
Thank
sir.
you. Okay, fine. So let us go for the shuffle function now. Okay, shuffle function, we have np dot a range of 20, and I'm just calling the shuffle function. It is giving a series of numbers. I just randomly want to shuffle the values. Yes, that is also possible. Okay, just give the shuffle. Okay. Okay, now I'm using the amin function once again. Okay, because it seems to be a bit different here. So I'm using something like amin. Okay, what amin function will do, we'll understand. Okay, so can you observe what is amin? What amin is doing? Anyone try to observe the output and tell me?
Minimum number in first row and second row.
Fantastic. Okay, so amin is giving the minimum number with respect to the first row and minimum with respect to second row. Okay, you are given something like amin of 1, make it as amin of 2. Now tell me what happens. What it says? It's axis error. This 1 and 2 is nothing but the axis. Okay, 1 mean to say the column axis. Okay, I'll put it 0. Let us understand what is there when I put 0. What it says? 0, 1, 2, 3, 4. Okay, it's the row axis and the column axis. Okay, in the particular row, if you want to extract with respect to the row, you want to extract with respect to the column, that's what we have. Okay, if you put 1, you try to axis with respect to the row. It's telling 0 and 5. Now if I put 0, you try to find out the individual element with respect to the column axis. Are you with me? Yes?
Yes, Vinay.
0 and 1 are the axis. That's it. Okay. The function. The function is amin. Okay. Amin is a function which finds out the minimum element present inside the array. As simple as that. Okay. And please don't worry. Once again, I'm telling you, Vinay, you're telling a lot of functions you're not able to remember. Okay. Please don't worry. I don't expect you people to by heart the things. Just keep in mind when someone says that, okay, I want to interchange the first row and the second row. Anyone? Which function will you use?
Shuffle.
Shuffle? No.
No, flip UD. Flip UD.
Flip, yeah, flip. Correct. So flip UD, right? So this is what I expect. Okay, this comes to practice. Okay, when someone says, see, there's an array element. Okay, and I want to find the minimum element present in that array.
Amen.
Yes, that's it. Okay, this you must be knowing. So I like this. Okay, this suddenly must flop. Like while working with programming, this comes by experience, right? This comes by practice. This comes by experience and practice. So more you learn, more you get used to this kind of functions. Okay. So suddenly someone says, yes, is there a function in Python in like I want to have a series of date from this date to this date. You can say the numpy will help. No man, import the numpy package directly in numpy. We have a function, use a range. In a range, give the data type as date. You get the series of dates. Simple. Someone will say I need a date difference. Date difference, that is also possible in numpy. Go to numpy and do it. This is what I'm expecting from you people to understand. Okay, they say I require some random numbers. Even next question must be, you require random numbers in terms of you require decimal number or integer values. Or you require decimal numbers, then use np.random.random. You want integer values, then use np.random.randant. Correct? No? Yes.
Yes, sir.
Yes. So this is a use cases what I want you to understand. Great. Okay. Fine. So here again I given axis is equal to 0. So x mean I given axis is equal to 0. When I given axis is 0, it will tell you with respect to columns. Okay, that is fine. Okay, this is important, which is respect to the percentile. Okay, I'm telling you with respect to percentile, this is important. Okay, observation, lot of observation is required in the percentile. You see, I'll be doing something called as, I don't know if I'm there or my colleague will take statistics classes for you. I'll just think of it. But with the statistics perspective, we have the concept called as when I go to pandas, we have something like describe function. There we'll be working with 75th percentile, 25th percentile. You will feel like, oh, all this we have learnt in our high schools. No, we are doing a revision. Yes. Okay, percentile concept, you don't even imagine that percentile concepts are really very very important in Python. I mean in machine learning. Okay, there is something called that outliers. There's something called as normalization curves. There's something called as skewness. Okay, all this stands behind statistics. There we keep on using individual statistics. What all you learned is median, mean. Okay, 25th percentile, 50th percentile, 70th percentile. All this we keep on using it. Okay, but as of now we can get the percentile of the value. Okay, see, I'll tell a simple scenario. Since I'm talking about the percentile, I have a scenario where I say, okay, how many percentage of the people, okay, are getting more than 75% of, when I say there are 100, out of 100%, 75% and above was the salary. Mean to say out of 0 to 100, let me say 0 to 100 is the range. Your salary getting like around 1 to 1 to, so like something like 1 lakh. Okay, how many percentage of people are getting a salary more than 75,000? Just get the percentage value greater than 0.75. So you'll be getting the count of the number of people who is having between 75 to 100. Can you try to imagine the use case? Yes? Yes or no? I'll repeat. There are something like 1 to 1 lakh people. I mean, the salary between 1 to 1 lakh. Okay, I want to understand. So out of 75%, 75% is 75,000. Let me say. So how many number of people are having the salary greater than 75,000? So what you get the values which is after 75th percentile. So you'll be getting the values who's the people who are having the salary greater than 75,000. Simple use case. We will see this in practicals, don't worry. Okay, if you're getting confused, please don't worry, because we'll be doing all these things. Okay, but advantage of percentile, because if you ask me real time where we use, I'm telling you. So what is this percentile? Here you'll understand. See, okay, I've given something like np.arange.2 comma 3. Okay, and I'm asking np dot percentile of x 90 comma 0. Mean to say that 0 mean to say it's an axis. That is very much sure now. Okay, I'm telling 90th percentile. What is 90th percentile of 0 to 3? Everyone? Am I with you?
Yes.
Shikant? What 90th percentile of 0 to 3?
90th percent
2.7.
from
Actually, because answer is there. Okay,
Yeah.
it's 2.7. Okay, 1 to 4 90th percentile is 3.327. Okay, 2 to 5 90th percentile is 4.7. Okay, 90th percentile mean to say that 90th value. I mean 90th value. Okay, see, percentile, when I say, it is something with respect. Okay, let me do one thing. I'll give something like 50. Now we'll understand. Yes? Got it. Abhi, are you getting it? Pooja, you're following?
I'm trying to follow.
You're trying
Sir,
to
if
follow.
please give once change the value,
You want me
percentile
to
value.
change the value. Percentile value?
Yeah,
Let me give 25.
yeah.
Okay, so I'll ask you before anyone can give a guess. So if I give 25, what will be the answer?
It's nearest to 0 point something.
0.75. 0.75 for 303.
Yeah.
Fantastic. 1 to 4?
1 to 4, 4.
1 point.
It is 1.25. 1.25. Okay.
1.7.
0.75, 1.75, 2.75.
Okay.
That's it. This 25th percentile. 25th percentile of 0 to 3 is this much. Okay. Following. Now if I give this 100, what happens? Huh?
Same result.
5.
Same one.
3, 4.
3, 4, 5. That is 100. That's the maximum value. That is correct, no? That's the
3,
maximum
4,
value.
5.
Now if I give 0,
0, 1, 2.
got it. Now if I give 90, you got it now, percentile. Yes or no?
Like,
Yes.
Yeah.
Yeah.
it's
So similarly, I tried it for rows. That's it. No difference. Okay, I tried it for rows. Okay, I just gave it as 1. Okay, so you must understand it is 1.8 and 4.8. Okay, for the rows, the axis I given it as 1. For the column axis, I given it as 0. Simple. This with respect to percentile. Man, why do we use percentile, man? Like, we don't know the applications you're seeing this. I'll tell you, percentiles and all, we'll be doing it in statistics. We have a separate session on statistics. That time we'll be doing it. Statistics is completely a theory process. Okay. We don't see much of practicals there, but there we'll now you'll be able to correlate. Oh yes, percentile we saw in Numpy, no, the same theoretically we are seeing it here. Okay, so we will see. Don't worry, we'll come to all these things. Okay, we have something like outliers, dimension analyticals, and all those things we'll be seeing that time. Okay, this is a median concept. Okay, this is a median concept. What is it, median? Okay, everyone knows about the median, no? Yes or no? Median, everyone knows.
Yes, sir.
Yes, sir.
I'm expecting everyone knows median because it was our 8th standard syllabus. Okay, so it would be our 8th standard. What is the median value? Median value is 0 plus 1 plus 2 plus 3 plus 4 plus 5 divided by 6. Yes, that is the average. Okay, it's an average. Okay, average. And what is the difference between the mean and the median? Median is the middlemost value. Mean is nothing but the average value. Correct, no? So given in 0, 1, 2, okay, given 0, 1, 2, 3, 4, 5, it says the median value is 2.5. How can you tell it is 0.5? If you want, you can take a pen and the paper, put a line of 0, 1, 2, 3, 4, 5. You can find out the middle element is 2.5 only. That is the median. Okay.
Yes,
Yes.
sir.
Okay.
Correct. When I put it at mean, here we have mean or average. I'm not sure. I think it's the mean. Yes. Mean is also 2.5. Correct, no? Did I showing that as median? That's okay, I can check it as mean. What is mean? Mean is average. 0 plus 1 plus 2 plus 3 plus 4 plus 5 divided by 6.
6.
Correct? This is about the mean value. Okay, so similarly I can find the covariance matrix. How to find out the covariance matrix in, that is again a different scenario. Okay, so finding the covariance of a matrix, please don't worry, people who don't know about finding the covariance of the matrix, but don't worry, I just wanted to show covariance of the matrix can be count. Okay, this is beautiful. Bin count. Okay, this is I'll see who can observe this. Can anyone observe and tell me what is doing? Bin count. Bin count. I'll see who can get it
It
fast.
counts how many times the number 1 is.
Somewhere near. But why you are getting 0?
It counts how many numbers? 0, 1, 2, 3, 4, 5. How many appears in next?
Very good, very good. Yes, yes,
Staying.
yes. 0, how many times it is there?
0
4
times.
0
times, but
times.
0 times.
Wherever one was there,
Yeah,
it put
1 is 4.
1 is 4 times. 2 is
2
2
is
times.
times.
3 is
2
0
times.
times. 4 0 times. 5 2 times.
Yeah.
This is bin count. Okay?
Yeah.
Yes. Good. People who are done with collections, okay, I don't know, I mean Python, advanced Python, when someone has done with advanced Python, we have a concept of collections. Okay, there we have something called as counter function works something like this, okay, in collections. Okay, people who don't know, don't worry, okay, it's not required for us. Okay, fine. So here we have shuffling np.a range of 10x before shuffling and after shuffling. Okay, shuffle random dot shuffle of x. Okay, shuffling just like how we saw in the previous case. I think this was repeated concept. Yes, this is very, very important. Okay, seed. Okay, I want you to understand this. Can you observe what is happening here? See, we will be using this in a lot of cases, and I tell you, most of the people, even now, like my juniors working in like with me, they actually don't know why they use seed. Okay, I'll tell you why we use seed. See, whenever we generate a random numbers, no, that random numbers we generated in it is a generic random number. I don't know what random numbers will be generated, but when you put a seed, when I put a random numbers and I put a seed as 12, you can observe whenever next time also when you put as 12, you'll be getting the same random numbers. For example, here I have random.seed and I'm putting it as 12. Okay, here also I'm putting random.seed and I'm putting it as 12. You can observe the random number seed is giving you the same numbers second time also. Here the seed is 12. When I generate a random number 4, you're getting 0.1541624. And here again I'm putting random.seed is equal to 12 and I'm generating a random number of 4. The numbers will be the same. Can you observe? Yes?
Yes, sir.
Yes.
When you give no seed, what happens? You're not limiting to the random numbers. You're not limiting to the random numbers. Okay, you're just telling it as, okay, you can give any numbers, boss. I don't care. Okay, this is with respect to without seed. When I say with seed, you must understand that, okay, it is giving you the proper random numbers. Okay, so what is the use case of it? The use case of it is that while working on the real-time application, okay, I say that I want I have trained my model. I've trained my machine learning model with row number 1, row number 3, row number 5, row number 7, row number 9 or something like that. I have used some particular seed. Next time I want to train one more time. I will not use the same seed. I will use a different seed, so that what happens for the second iteration, it will select the different rows. Correct? No, I have given 100 rows and I had given random seed. I given a seed as 1. So when I given seed as 1, 1, 3, 5, 7, 9, 11 would have been selected. When I give seed as 3, then 1, 2, 3, 4, 5, 6, 7 would have been selected. Are you following? Yes or no?
No, Vinay. I did
No.
not get that.
See, say like when I say seed function, the seed function will give you the different value. For example, you have 100 rows with you. Okay, you have 100 rows with you, and I'll give the seed as 1. When you give seed as 1, random number, random numbers, and the random numbers are given a seed function as 1. So row number 1, 2, 3, 4, 5, 6, 7 would have been selected when you give seed as 1. Let me say you're given seed as 2. Then in that case, the random number selected would be 1, 3, 5, 7, 9, 11. Given the random seed you're given as 6, then it will be selecting like 1, 4, 11, 13, something like that. Okay, so the seed will fix that these are the numbers to be selected in random.
Vinay, I got that. I got that. What I'm not able to understand in the machine learning example that you gave, I
Okay.
just can't get my head around. It deviates the whole purpose of random function, right? The random is meant to give random numbers, and then we are fixating those numbers by seed.
Yeah,
Why would
I'll tell
we
you.
do that?
I'll tell you. I'll tell you. Okay, I'll tell you. Just we have one more session for today. Please don't mind. Okay, we'll be connecting with one more session. Okay, I understand it's a huge time, but please bear with me. We'll be having one more session. I'll be giving a new ID and the password. We'll connect. Okay.
Okay.
Thank you. Okay, so we'll be continuing like what exactly the seed and why are we using the seed function. Okay, so since we saw the scenario, let me say that I'd given the random seed. Okay, so you understood what seed will generate. Okay, so seed will generate a random numbers. When I say 4, always it will give me 0.154, 0.74, 0.977, 0.266, something like this. Okay, so this is something which is being given. So how this will be helping with respect to machine learning? If I don't give the seed, let me say if I don't give the seed, and if I give some values like so generate some random numbers, random of 4. Okay, so there is a probability, there's a chances in a way that, okay, the first time if I ask, the first time if I ask, it would have been selected row number 1, 3, 5, 7, 9 for the training. Next time if I ask, I might get something like this, where it might get something like 1, 3, 5, 7, and I don't know, I'm not sure. I might get the same values when I use random. But if you use the seed function, for sure, okay, when you use something like 1, 2, 3 as one seed, next time if you use 1, 4, 5 for the second time of training or something like that, okay, the seed value, the number which has been generated here is completely absolutely different. The number which is selected here will be absolutely different. So what happened while training my machine learning model, if I use the seed different for different time, then my model will not be biased. Mean to say it will not be biased, because it will be learning with the different rows for the first time, it will be learning for the different rows for the second time. Did you get it now? Pooja, did you get it?
Yes, yes, I got it. I
Sure.
got it. I just was wondering, why. So there is a justified use case of why we want to use random function, because we want to use random numbers, and then with seed we are doing the opposite. We are fixating those numbers. So I was just
Right.
trying to understand why we are doing
I know
that.
you got it. See, and I'm speaking with respect to indexes. I'm not speaking with respect to the random numbers. So once when I generate some seed, some random numbers, I'll assign it to the index. Index when I say row numbers. Okay, it will be giving you the random numbers. That random numbers I'll be setting to index. So I'll be selecting the different row numbers, like row number 1, row number 3, row number 5. It might seem to you as a number, but I'll be setting it as an index. Got it?
Yeah,
Okay, good.
thank you.
Fine. Good to go. Fine. So this is about the seed. And next one is the difference. Okay, we are trying to find the set difference 1D. Okay, we are trying to find the set difference 1D. So what is the output in this case? 0, 1, 2, 5, 0, 0, 1, 4. So difference in terms of not a subtraction what we are doing here. Okay, here it is finding out what is present in x and what is present in y. Apart from what is not present in x, we are just getting that. I mean, what is present in x and not present in y, that we are getting as an output, which is 2 and 5. Okay, that's all about us. And the next function is giving the scientific notation. Okay, scientific notation in terms of, if you can see, when I put, okay, I put actually suppress is equal to false. When I put suppress is equal to false, then the scientific value of a particular numbers is not being given. For example, here when I have 1 minus 2 exponential of minus 10, this 2.1 and 2.3 and all those things. Okay, so here 1.2 exponential of minus 10 is nothing but 0.00000 some huge value, right? Okay, but it will be giving it as 1.2 exponential of minus 10 usually. Okay, but I can suppress the scientific value. When I suppress the scientific value, we'll be getting only the values which is present after that. Okay, you can just see this. You got it? Suppress is equal to true will suppress you the scientific value, but never you do that. You always want the exponential value also. That's the reason we give suppress is equal to false. People who feel like, what is this 1.e to the power of minus 10 is nothing but 1.2 to the power of minus 10. Okay, so 10 to the power of minus 10, it is 0.0000000. It keeps on point 0.0000012. So series of zeros, then it is something exponential value. Okay, exponential values. Right, so 2.3 to e plus 0.1 mean to say 2.3 into 10 to the power of 1. 2.3 10 to the power of 1 is nothing but 2.3 into 10. 2.3 into 10 is nothing but 23. Basic mathematics, a very basic mathematics. Okay, but if you want an exponential value, we can give exponential value like this. If you say no boss, I don't require exponential value, okay, I want it the value as it is, then you can say suppress is equal to true, so you'll be getting the actual value. Am I with you? Got it? Yes or no? Arun, got it?
I got it. I got it, Vinay.
Sure. Sahana?
Yeah.
Thank you. Got it, Sahana. Pooja, you got it? Bona?
Yes, Vinay.
No,
Megha, following?
Yeah, sir.
Good. I know it's a
Hello.
long day. It's a long day for us. Yes, tell me. Yes, yes. Ask
Sir,
the
can you
question. Good. Which one, Bomana? Which one you want me to repeat?
that was suppressing.
See, this is all about the scientific notation. See, for example, we have something like 1.2 e to the power of minus 10 mean to say is nothing but 1.2 into 10 to the power of minus 10. Okay, rather than representing it as 1.2 into 10 to the power of minus 10, we are representing it as 1.2 e minus 10. Okay, if you say I don't want that e and all, it looks something very clumsy for me. I don't want some exponential values to be displayed. I want the numbers as it is. Then you can give something like suppress is equal to false. So that exponential value will will be removed and you'll be getting the actual value. That's it. Okay.
Sir.
Okay.
Yeah.
Okay, this is again the simple example. You can just revise this concept, which is subject to converting the floating value to integer, integer value to floating. Okay, typecasting what I'm doing. Okay, then comparing the date time. Okay, I've taken the same example. I tried to cover almost everything in this file. Okay, almost everything is covered. Okay, so which was missing, I tried to do it, and which are really not required, that I have removed and I altered this file. You can just revise this file. You'll get to know a lot of things. Okay, date comparison has been done. Okay, and here you can see I'm comparing two different days. It will tell whether which is true, which is false. This has been done. Okay, then np.arange. Okay, we'll be getting the numbers from 0 1 2 3, and I can reverse it, which is a single value. X is to minus 1. When I give x is to minus 1, doesn't mean it is simple mean to say that it is 3 to 1 0. This can also be done using one more function. Can you tell me what was it?
Flip LR.
Yeah, flip. That's it. Flip LR. Very good. Fantastic. So if you can do flip LR, the same happens. But that can also be done using x is to minus 1. So y is to minus 1 is the syntax. The syntax to reverse the array element. As simple as that. Okay, that's all about this. So can we revise the 2D? Can we reverse the 2D array? Yes. For 2D array, I told you we can use flip UD, flip LD, flip RD, what we discussed in the previous classes. If you want to work on the one-dimensional array, you can use something is to minus 1. If you are in 2 dimension, then you can use a flip. Okay, then can we delete the specific indices? So we have 1 3 5 4 7. I want to delete the second position and the third position. Just use a delete and say a comma indices. Delete what? Delete from a. What are the indices? Indices are 2 and 3. So when I run this, what is 2 and 3? 1 3 5 4 7 is there. 0 1 2 3. 0 is 1, 1 is 3, 2 is 5, 3 is 4, 4 is 7. I'm removing 2 and 3. So it's nothing but I'm removing 4, 5 and 4. So when you print this, you'll be getting 1 3 and 7. So delete is a function which is used to delete the array element given in the specific index. Correct? No? Yes?
Yes, sir.
Okay, thank you.
Yes, Vinay.
Okay, good. Fine. So delete a specific element. Okay, I can delete the specific element using the set difference of a comma b. Okay, if we can say I have np.array which is a, and I have np.array which is b, which is 3 comma 4, and I do set difference of one dimensional. So what it will do is it sets the difference. So element which is present in a and which is not present in b, that element will be getting it as an output. Simple, what we saw in the previous case. Okay, and one more important value, what we have, something called as np.nan. NaN, we to say it is not a number. Okay, I'll repeat, NaN, we to say not a number. Okay, not a number in terms of, usually whenever we read from the files from CSV, right, if there are missing values present in the CSV, I repeat, if there is missing value present in the CSV in pandas, pandas is the next concept what we do from the next class. Okay, when we read a CSV file, if there's a missing values in the file, you will not be getting an output. The values will not be 0. It will be as NaN, or not a number, or NA, not assigned. Either it will be NaN or NA. Okay, mean to say the value will not be blank. Because when you read the particular CSV file to the Python, if there's a missing values, the missing value will not be blank. Either it will be filled with NaN or NA. Either one of this. Okay, so what we'll be doing here. So I say np.nan of a is 2. Okay, so what we'll be getting, let us see. Okay, so it says everywhere it will be assigned as nan. If you ask me, is nan a particular data type? Yes, it can be considered a data type. Okay, it says that nan is a, it's like, it assumes that there is no number, there's nothing has been initialized. That's it. Okay, it's an empty. Okay, empty set itself, there's no value inside it. I told you real time scenario, whenever you read a CSV file or when you try to connect to database and there are few values which has been missing. Okay, in that case what it will do is it will not give the blank spaces, it will not fill some underscore. It will usually, whenever we read in Python or in pandas data frame, it will be given with a value called as nan. So NaN mean to say that the value is not there. That's it. Okay, so here we have something like replacing some particular position. This also we have already discussed. Okay, so here we have np.random.random 2 comma 4, and then I say a of a greater than 0.5, replace that to 0.5. So in the a, I'm going for the particular position of a, and in a, if something is greater than 0.5, replace it to 0.5. That's it. So that is a simple operation. What I'm doing is that is replacing the specific position. This is what we are doing it here, and we have one more function called as roll. Beautiful function. So roll, what it will do is, okay, I have 1 2 3 4 5 6, it rolls, it rotates. Okay, what is happens here is it says 1 2 3 is there, 3 comes and sits here, 1 here, 2 here. If I do roll one more time, then again it flips. Okay, it flips. So this is with respect to the roll function. And given axis is equal to 1, so it is moving with respect to the rows. If we give axis is equal to 0, it moves with respect to the columns. Okay, so roll mean to say it rotates one time, it shifts the numbers one time. Okay, this with respect to the roll function. I have tried the roll function with the value column also. You can observe the columns 1 4 is there, the 4 1 will happen, 2 5 is there, 5 2 will happen. This with respect to the roll of the elements. Okay, I am just given some multiple examples of the roll, so you can look into it. It's not so difficult, you can just look into it. Okay, so this is with respect to index command. Okay, index command in terms of I have np.array of 11 20 to 45 so and so, index of 4 2 0 1 and 3, a of index of b, mean to say that whichever is having the particular index, I'm just pushing it. For example, 4 2 0 1 3 is there, what is there in the fourth position is 55, second position what we have is 33. Okay, 0 position is 11, so I'm telling index of a of index, so mean to say that whatever is present in the particular index position, a of 4, a of 2, a of 0, that is been taken in the order, then we have replaced it. Okay, rearranging with specific index. Okay, very simple concepts, but just keep in mind all this can be done. This is very important. Okay, this is called a serialization. Okay, serialization in terms of whenever you're storing the data or whenever you're pushing the models to live or to the server, what we do is we usually serialize. People are already working in industry would have been knowing this serialization in terms of whenever I want to push some libraries or push some model. Okay, it will not be in the original format, we will be serializing it, that is we'll be converting it to the binary format. Okay, we'll be converting to binary format, so we'll be doing something called as serialization. So when I want to push some data through the network, either it might be through the security for the security protocol, or it might be to storage to store some value in the disk. Okay, what we do is we directly don't store the value, we will serialize it. When you serialize it, it is important, it is not it will be, it is important for us to deploy it somewhere. If you want to deploy it somewhere, it is not in a normal format, it has to be in the serialized format. We have to serialize the data. For example, we have 10 and 20, and if I want to serialize it, I'll be using something called as pickle. Okay, this pickle, what it will do is it will serialize the values. What do you mean by serialization? I'll show you. See, 10 comma 20 serialized numpy array will be like this. Okay, the exact, I know it is hexadecimal value, lot of things are happening here. Okay, this is a serialization, and I can deserialize it. Deserialize in terms of I can deserialize using this deserialize function, like pickle.load. Okay, so pickle.dump mean to say that, okay, it is dumping. When I say pickle is a library which is used to serialize. I repeat, pickle is a library to serialize. Why do we serialize? Question number 1. Why do we serialize? Because while working on the deployment and by if you want to store the physical file, we always expect to be serialized. I repeat, while working on the if we want to deploy the particular model, or if we want to save the particular model into the disk, we always expect it to be serialized. Okay, it is a common protocol what we usually follow, right? So it's like we want to serialize it. So how to serialize the data? To serialize it, okay, we need to use a function called as pickle. For example, I had built a machine learning model. I'll tell you, I built a machine learning model, and after building the machine learning model, okay, I will say that I just take it as an API. Okay, I take it as an API, and I'll take that API and I'll give it to the front end people. Let me say a front end developers. Okay, when I give it to the front end developers, so they will ask me in terms of API. Okay, when I want to give in terms of API, what I'll do is I'll say I'll give you in the pickle format. Okay, I'll give pickle format. I'll dump the file in the pickle format. Then I will give it to them so that they depickle it, or else they can call it as an API. This I'll be doing it in practicals. Don't worry. Okay, how to work with the pickle file, we'll be doing it. Okay, at the end, at the project, while working on the project, that time I'll be telling you how to convert your model to pickle file, and that model will be read as a pickle file. But what is this serialization? Okay, people who already working in industry, you can understand. Freshers, please don't worry. Okay, pickle mean to say that we are converting from a non-serialization of serialization or non-serialization to serialization. That is, we are trying to convert it to the serialized format. That's it. So how to serialize it? Using the pickle. Why do we do it? It is preferred. It is always preferred to serialize the file when we are sending over the network or while storing it in a disk file. I repeat, whenever you are we are sending the data, it is common. It is common in all the projects. It is in Java, or it can be C Sharp, or it is C++. Everywhere it is the thing which has to be done. Serialization. That is converting from the actual format to serialized format so that it can be transferred over the network, or it can be stored to the physical file. For well, that case we will serialize it. After we load it, then we deserialize, so that it is something like a part of encryption. Okay, that is all about the serialization concept. Just keep this in mind. Okay, and anomalies. Okay, so it's just like, I'm just giving for NP in range of 0.02, mean to say that if you ask me, Vinay, is that only we'll be getting the values in A range, only the decimal, non-decimal values? No, we can also get like this: 0.1, 0.2, 0.3004. Okay, what is this? NP dot A range 0, 2.1. Every time we are getting the values. Okay, which is like this 0.6. But whenever you get 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, the series of values. If you ask me why this 0.3004, 0.400 has been getting, I can show you. Let me tell a scenario. Okay, let us take a scenario where I'll give it as simple. Don't get confused. I'll give 0.2 to 2. Okay, so what is happening here? You're getting something like 0, 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, 0.8, 0.8, series of numbers. That's it. Okay, so what I want you to understand here is, okay, we can also get the floating numbers in A range. As simple as that. If I give something like 0.029 and 0.1, you get like this. I'll say I'll start from 0. Okay, I'll say something like 1. Start from 1 to 9. Okay, 1.0, 1.2, 1.246. Okay, this is the values. So is there any specific reason that we are getting only 1.0, then we are getting 1.1, 1.2? Okay, even I have not observed why it is actually 1.1 for 1.1, that is 1.2002 for 1.2. I have not observed this. If you want, I can let you know. Okay, but yes, so A range is possible for the decimal values also. That is what I wanted you people to observe here. Good to make sense. Okay, good. And resize. Okay, let us see what resize will do. Okay, 10, 20, 30. Then I told resize automatically this list to 12 elements. We have only 3 elements, 10, 20, 30, and I'm resizing it to 12. So automatically it will be rest of the numbers gets concatenated. It says 10, 20, 30, 10, 20, 30, 10, 20, keeps on repeating, because you've asked me for the 12 elements now. So if you say I require 11 elements, so what happens in this case? Let us see. So 10, 20, 30, 10, 20, 30, 10, 20, 30, 10, 20. That's it. So automatically, if you want to fill the elements, you can use something called as resize. This is about the resize function. Okay, and the last function is, we have something like business day count. This is also possible in Numpy. I don't know what not is not possible. Okay, so I'll just run this. Right, so you can see how many business days are there between 2020-01 to 2021-01. It also says there are 262 business days. I think it is continuing, it is skipping Fridays, Saturdays. Okay, we can just see to it. But it says the business day count. We can change it. We can change the business day count. You say that you can go to the function and you can say the business day count Saturday must also be considered. There are a few modifications which can be done. But business, we have something called business day count, which will be telling you how many number of business days were there in a particular year. Okay, so this is all the basic functionalities which is there in Numpy. We saw a lot of functions in Numpy. Just revise this file. I've uploaded this file in the portal. You can just see to it, revise it, try to do it on your own so that you will clearly understand how it can be done. Okay, so doesn't mean to say that we need to buy out all the functions. Okay, I tried to cover the functionalities which I felt it is important. Okay, doesn't mean to say that we need to buy out all the functions, but what we did in the session 1, something like how to create an array, how to create an array of zeros, how to create array of ones, how to reshape it. okay, and how to find the how to find a determinant. All these functions you'll be using a lot. So I made it as two different files. One is the use cases, which you need to remember, which is just you can just revise it. And the first one was the basic functions, which is very, very important to understand. So this is all about NumPy. Okay, you'll be giving an assignment. They will be given an assignment with this week on with NumPy. I assume that people have submitted the Python assignment, and there will be a session. There will be a quiz on Python perspective. I want people to be ready for the quiz. Okay. Have a nice weekend. I wish you people to have a nice weekend. Thank you for your time. Have a good day. Bye bye.